Hey guys, tonight we drift into something the universe has been doing for almost 14 billion years. But lately it's been doing it in a way that feels oddly sluggish, like a giant that woke up too fast and is now rubbing its eyes yawning and deciding to stay in bed for just 5 more eons. You're floating here with me right at the edge of where light turns thin and quiet, watching the cosmos stretch in slow motion. Stars blink like tired street lamps. Galaxies slide apart like friends who promised to keep in touch but didn't. And you, tiny, warm, extremely breakable, you are suspended in all this gentle cosmic laziness. And yes, you probably wouldn't survive this vacuum for more than a heroic half-second. But that's part of the charm. The universe is lethally peaceful. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And go ahead, drop your location and your local time in the comments. I love seeing all the little pins of consciousness across our drifting world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin by imagining the universe as a giant creature. Inhaling only its breath is so slow that even mountains would get bored watching it. You hover within this breath, this expansion, and you feel it as a faint, almost whisper-level tug on everything around you. Scientists call this the Hubble expansion, but you feel it as something softer, something that nudges galaxies apart with the gentlest push you can imagine. The fun part, that push used to be fiercer, much fiercer. Back when the universe was young and rowdy, expansion raced outward like a toddler with new legs. Now though it moves with the calmer pace of a retired marathon runner who's discovered the joys of not running. That's your first mainstream fact. The early universe expanded insanely fast, faster than any explosion you could ever picture because of something called inflation. That initial blast made today's cosmic stretching look like a lazy Sunday stroll. As you drift, you picture the universe cooling down after that sprint. It didn't stop expanding, it just settled. Like the way the buzz of excitement fades after a long road trip, and everyone falls into that soft, companionable silence. Scientists still argue whether the universe is genuinely slowing down or simply switching gears under dark energy's influence, but the vibe is clear. Space feels calmer. You float past ancient light photons from the universe's baby pictures, and you notice how they seem tired. These photons left their source full of energy, bright and punchy, but by the time they reach you, they've stretched into a pale glow, the cosmic microwave background. That's the afterparty of the Big Bang, and it's dimmer every year, literally. The universe is stretching light into longer and longer wavelengths, turning fiery baby universe radiation into something closer to a cosmic sigh. You drift with those photons, feeling how the universe's expansion treats them like taffy being pulled apart. This is where the quirky fact sneaks in. There's a fringe idea floating online that the cosmic microwave background might contain hidden messages or patterns left by civilizations from previous universes, like cosmic graffiti. Most scientists roll their eyes, but you let yourself smile at it. It's harmless, it's fun, and it makes you wonder whether the universe leaves Easter eggs for those with enough caffeine and telescopes. The galaxies around you glow faintly like lanterns floating downstream. They slide apart so slowly you can't sense the movement directly. You only feel the widening emptiness between them. Expansion used to be all fireworks and chaos. Now it's like the universe has put a "please speak softly" sign on the door. And you drift along that quietness, letting it soak into your breathing. If you listen closely, yes, I know space doesn't carry sound, but just pretend you can almost hear the tension leaving the cosmic fabric. Gravity, as mighty as it is, doesn't fight as hard anymore. Like an old wrestler who finally admits he doesn't need to win every match. That's because the distances between galaxies have grown so large that gravity's influence stretches too thin to keep holding everything together. You feel that loosening the way distant galaxies stop caring about each other's presence. Scientists still argue whether this long-term drift is permanent or if someday expansion might reverse. A few fringe thinkers even suggest that cosmic laziness could lead to a slow bounce where expansion eventually flicks into contraction, like a cosmic front seat recliner being adjusted. Most astrophysicists disagree, but the debate hums quietly in the background like a late-night talk show no one quite agrees with but still watches. A dim red galaxy passes by your field of imagination. Its light, once bright blue and fierce, has stretched into a sleepy amber. That's the universe telling you it's getting older, not dying, just relaxing, like wearing sweatpants for the first time after a long workday. You drift deeper into this cosmic rhythm. Every particle, every beam of radiation, every galactic cluster seems to be exhaling. You feel how distance itself becomes something softer, slower, less urgent. Even time feels different. Out here in the hush of cosmic expansion, a minute stretches like warm molasses. You begin to suspect that the universe doesn't just expand physically, it expands emotionally. It invites you to unclench. And in that slow exhale, you sense the first real truth of our journey. The universe isn't racing toward its future anymore, it's strolling, wandering, stretching out its limbs like someone waking from a nap that lasted 13 billion years. There's no hurry, no finish line, just endless expansion growing fainter, quieter, lazier. And you drifting inside it begin to match its pace. You drift onward without pausing, letting the thinning glow of the early universe wash over you like the last warm ember in a dying fire. The afterglow sits around you, the cosmic microwave background, quiet uniform, strangely comforting. It feels like the universe's baby blanket still wrapped around everything even after billions of years. And tonight you glide right through it like someone brushing their fingers across old wallpaper in a childhood home. This ancient light is faint, only a few degrees above absolute zero, but it carries stories. You can almost imagine the photons whispering to you, "Hey, remember when everything was chaos and plasma soup?" Yeah, we've mellowed out. These photons have travelled so far, stretched so thin that they barely qualify as light anymore. Scientists say the cosmic microwave background temperature drops a tiny bit every century, just a whisper. But as you float here, you can feel that whisper as a soft, ever-cooling breeze. You move through it like wading through fog, not a heavy fog, more like the haze that clings to a lake at sunrise. This is the afterglow that started everything. And you can sense, almost physically, how much it has changed. When it was born, it blazed at thousands of degrees. Now it's calm, it's sleepy. It's the universe's version of jazz played at 2 a.m. in a nearly empty bar. Here's your scientist's approved fact for this stretch of your journey. The cosmic microwave background isn't just background decoration. It's evidence that the universe was once scorching hot and dense. It's the fossil light from when atoms first formed about 380,000 years after the Big Bang. Before that moment, the universe was too energetic, too chaotic, too opaque to let light travel freely. Everything was bouncing around like toddlers in a trampoline park. Once atoms settled down though, once protons and electrons finally said, "Let's make this official," light was free. It streamed outward, and it's still streaming. Only now it's stretched into something unimaginably long and lazy, like an old cat sunbathing across your rug. You glide deeper into this panorama, feeling the texture of the early universe on your skin, even though you technically don't have skin here. The temperature is nearly uniform, but not perfectly so. There are tiny fluctuations, ripples like wrinkles on a slowly deflating balloon. And these wrinkles matter. They're the seeds of galaxies, clusters, superclusters, the scaffolding of everything we see today. But as you float, you also sense a debate simmering beneath the quiet. Scientists still argue whether those tiny temperature ripples were truly random, quantum fluctuations amplified during inflation, or if something more exotic nudged them. Some fringe theorists whisper about pre-Big Bang structures imprinting their fingerprints onto this afterglow like echoes from an earlier universe, hitting the walls of ours. Most physicists treat that idea the same way you treat a friend who insists horoscopes can predict tax refunds may be fun, not exactly reliable. But the debate is there, floating with you. You pass through one of those tiny fluctuations, a region just slightly denser than the rest. In the early universe, this spot would have drawn in matter little by little, until gravity sculpted a galaxy. But here in this drifting perspective, it just feels like a slightly warmer patch of cosmic memory. Not warm enough to toast a marshmallow, but enough to say hello. As you drift, you let yourself imagine what this light looked like billions of years ago, more energetic, tighter, more focused. The expansion of the universe has stretched it like a rubber band pulled far beyond the point where it snaps back. And that stretching feels lazy to you, like the universe is growing less enthusiastic about keeping everything bright and energized. The farther light travels, the redder it gets, the more it yawns, until eventually it'll slip into wavelengths so long and so low energy they might as well be cosmic daydreams instead of photons. You glide past a particularly faint patch and feel how quiet it is. The silence here isn't the absence of sound, it's the absence of urgency. Nothing is rushing, nothing is arguing. Even the particles that once zipped around at near-light speed now drift with the slow patience of retirees feeding ducks. And in the middle of this loneliness, you feel a tug of humour. You're drifting through photons that left their origins before Earth existed, before the Sun existed, before even the Milky Way fully settled into its spiral shape. And yet here you are imagining all this while wearing maybe a t-shirt with a coffee stain you still haven't washed out. The universe has scale and you have laundry. A tiny quirky idea nudges itself into your thoughts. A fringe speculation that people occasionally whisper about. What if the cosmic microwave background contains conscious information? The notion is far from mainstream, but some imaginative souls propose that the patterns in this radiation encode something like universal memory, as if the Big Bang wasn't just an explosion but a message. Scientists don't buy it, of course, but you smile anyway. It's late, you're drifting. You're allowed to entertain cosmic weirdness. The glow gently thins as your imagination glides through it. You begin to sense how this afterglow is fading over time, not dramatically, but inevitably. Eventually, the cosmic microwave background will cool so much stretch so far that it becomes practically undetectable. The universe is pulling it into a kind of cosmic retirement home, and you feel that slow pull, not like a force but like a mood. The universe's early roar of light has become a sigh. Expansion isn't just stretching matter, it's stretching stories. Everything is becoming softer, longer, quieter. Scientists still argue whether dark energy will eventually stretch this ancient light beyond any hope of measurement, or if some future civilization, maybe human, maybe something stranger, might invent instruments sensitive enough to hear even those faint cosmic murmurs billions of years from now. The debate drifts with you, gentle and unresolved, like a lullaby missing its last note. You float on, letting the afterglow brush against you like warm dust. You realize how much this ancient radiation shapes your understanding of the universe. It's a map, a memory, a photograph of the cosmos before galaxies learn to spin and stars learn to burn. And as the light dims behind you, fading into tones too subtle to picture, you feel the narrative shift. The universe's early fire is giving way to something softer, slower, sleepier, just like you. You keep drifting, letting the last hints of the cosmic afterglow fade behind you, like the dimming lights of a distant town you've left far, far below. The universe in front of you feels softer now, not just visually, but emotionally. Space itself seems to loosen like a sweater stretched one size too big. You take a slow breath and imagine your lungs expanding like the cosmos. Though to be clear, please don't try to inhale the actual vacuum. It's a terrible air substitute. As you glide forward, you notice something subtle. Space doesn't feel bigger in the dramatic firework explosion sense you might picture. It feels thinner, more spacious, yes, but in an airy, diluted way. Everything is spreading out not like an explosion, but like watercolor bleeding across paper. The colors go pale, the edges soften, and everything that was once bright and loud grows hushed. This is the part where the universe reveals one of its most underrated truths. Expansion doesn't make things more chaotic, it makes them quieter. You drift through a region where galaxy clusters used to be a little closer, just a cosmic handshake away. Now they're more like acquaintances who occasionally wave across a football field, but don't bother walking over anymore. The stretching of space doesn't rip them apart, it gently eases them away from each other. Here's your mainstream scientist-approved fact for this section. As space expands, the density of matter decreases, not because matter disappears, but because it occupies more volume. This dilution slows down interactions. Gas clouds collide less often. Galaxies merge less frequently. It's like cosmic social distancing, but with fewer arguments about masks. You slip into that thinning, almost airy fabric of space-time. You feel how energy spreads out. Every beam of light becomes a little less punchy, every particle a little more solitary. Imagine taking a scoop of soup and pouring it into a giant swimming pool. You still have soup, it's just a very disappointing one. The universe is doing that with everything mass-light heat structure. You extend your hand, yes, imaginary space hand, and run your fingers through this diluted cosmic fabric. It feels like touching the surface tension of a bubble. Delicate, stretched, a little tired. If the early universe was a boiling cauldron, this late-stage universe is a cup of tea you forgot about until it went lukewarm. And here, right in the middle of this quieting expansion, you pass by a galaxy that looks like it's been caught mid-sigh. Its spiral arms loosen, its stars drift more lazily. Out here, collisions are rare now. In the early universe, galaxies slammed together like over-caffeinated bumper cars. Today they drift like old boats in a tide that doesn't have the energy for waves anymore. You can almost feel those stars slowing down their frantic birth rate. Less gas colliding means fewer sparks, fewer newborns, fewer cosmic tantrums. Space feels more like a library reading room than a fireworks factory. Still, scientists argue whether this slowdown will continue forever. Some propose that pockets of matter might clump again, defying cosmic laziness in local neighborhoods. Others debate whether dark energy might eventually accelerate expansion so much that matter will be stretched into irrelevance. The arguments float around you like grad students whispering in a hallway. Then a quirky bit of fringe thinking taps you on the shoulder. There's this playful idea online that the universe isn't expanding at all, instead you are shrinking. Everything they say, from atoms to rulers to your favourite snack, is slowly reducing in size, giving the illusion of expansion. It's absolutely not supported by physics, but it's the kind of brain teaser you think about at 2 a.m. when you're supposed to be asleep, but instead you're wondering whether your couch is being stretched or you're just becoming less couch compatible. You let that absurd little thought amuse you as you continue drifting. The space around you becomes even softer, like the quiet moment after snowfall, when everything is muffled and feels strangely sacred. You sense how the universe's expansion doesn't push you, it makes room for you. It's subtle, gentle, almost polite. If the universe had a personality, it would be that quiet friend who always gives you extra elbow room on the couch. As you float the light around you grows fainter. Photons stretch further into the red, then into the infrared, then into wavelengths you can no longer picture. They're not disappearing, they're just tuning into channels your imagination isn't subscribed to. Somewhere out there these waves still hum but softly. Like a lullaby whispered through a pillow. You inhale slowly again metaphorically, since real inhaling is discouraged in space, and feel how the universe's expansion mirrors your own exhale. Things drift away, tension leaves, pressure drops, everything settles into a more spacious version of itself. Then you notice something almost comical, a lonely hydrogen atom drifting by, at maybe 1 atom per cubic meter. You wave at it, because why not? In cosmic terms, that's practically a crowd. Long ago, that same volume of space would have held trillions of particles zipping around, bumping, interacting, arguing about quantum mechanics. Now it's emptiness with occasional decoration. Scientists still argue whether this thinning out of matter will eventually lead to an era where interactions become so rare that nothing new ever forms again. No stars, no planets, no amusing asteroids shaped like potato wedges. Just quiet. Endless quiet. And yet despite the thinning, you don't feel lonely. There's a strange comfort in this softness, as if the universe is giving you space literally to rest, to drift without urgency, to let your mind wander like starlight being redshifted into a long lazy wavelength. You float onward, and as the cosmic fabric continues stretching, you feel that gentle loosening in your thoughts too. You stop gripping so tightly, you let yourself drift. Things slow down not because you force them to, but because the universe itself seems to be suggesting, hey, it's okay to relax. Everything's getting quieter anyway, and you drift with it. You drift deeper into the soft stretch of space, and something new begins to tug at your awareness. Not a force pulling you, not a sudden shift, but the absence of something that used to hold everything together with fierce determination. Gravity. That old cosmic disciplinarian. Once upon a time, gravity was the loudest voice in the universe, clumping matter, sculpting galaxies, bending light like a show-off at a cosmic yoga class. Now though, it feels like gravity has eased into middle age and finally learned the meaning of delegate. You can sense it as you move a gentle surrender. Galaxies that once pulled toward each other with the enthusiasm of long-lost siblings now drift apart, like people who realize they don't actually have that much in common. The gravitational bonds aren't gone, they're just mellow, softer around the edges. You float between two galaxy groups that used to be exchanging matter, flinging stars back and forth. Now the distance stretches subtly, and the exchange slows to a reluctant trickle, like neighbours who used to borrow sugar every week, but haven't talked much since one of them got a new job. Here's your solid, scientist-approved fact as space expands. The effective gravitational pull between distant objects weakens because the fabric of space itself is stretching faster than gravity can compensate. Gravity isn't failing, it's just outpaced. Imagine trying to pull someone toward you while standing on a treadmill that's slowly drifting backward. You glide between these enormous structures and feel how the universe is quite literally loosening its grip. And in that loosening is a strange, peaceful beauty. Clusters of galaxies used to tug on each other, merging, wrestling, translating mass into motion. Now they drift in gentle spirals, content in their own isolated bubbles of gravitational influence. You picture gravity like an old sea captain who spent billions of years steering the cosmos, whipping up stars, corralling planets, herding gas clouds into orbiting families, and who's now sitting on the upper deck of a ship sipping something warm, watching the galaxies drift apart with a sigh of, well, I've done enough. Scientists still argue whether gravity's influence will eventually lose the cosmic tug-of-war entirely, or if local gravitational pockets, galaxies, groups, clusters will remain bound forever while the rest of the universe stretches beyond reach. It's one of those debates where both sides bring charts and simulations and leave the room still convinced they're right. As you hover near the edge of a galaxy cluster, you notice the stars on the outskirts. They feel the weakening first. They orbit slower, more loosely, like dancers who no longer feel the urge to stay in tight formation. A few of them drift into intergalactic space rogue stars, lonely wanderers shining into the void. They move through the dark like tiny lanterns in a vast cave. No destination, no hurry, just drifting. Then the quirky fringe idea of this section sneaks in like a guest arriving through a side door. Some theorists playfully suggest that gravity isn't actually weakening at all. It's leaking into extra dimensions. According to them, the universe might be losing gravitational strength the way you lose socks in the laundry, not because something is wrong, but because it slips somewhere you can't see. Is it true? Absolutely not proven. Is it entertaining at 1 a.m. while you drift through imaginary cosmic fields? Absolutely. You float near a pair of galaxies that are just barely gravitationally bound. Once they were on a collision course. Billions of years later, the collision hasn't happened. Doom postponed, drama cancelled. Instead, they revolve around a shared centre, like two tired house cats circling a warm patch of sunlight. Eventually, even their mutual attraction may fade as expansion stretches the space between them faster than their pull can compensate. But locally, within galaxies like the Milky Way, gravity still rules. Stars orbit the centre, planets orbit stars, moons orbit planets, and you orbit your fridge at midnight when your stomach remembers leftovers. But on the big scale, gravity is surrendering the battlefield. Like a grandparent who smiles and says, "You kids figure it out." You glide farther, noticing how even dark matter halos, once sharp, crisp, skeletal frames of galaxies, start to feel less rigid at the edges. They're still there, still essential, but a little more diffuse, a little more relaxed, maybe even casual. Imagine dark matter wearing sweatpants. Scientists still argue fiercely about the nature of gravity itself, whether it's a force, a curvature of space-time, an emergent property, or something even stranger. But here in this drifting softness, you don't need to pick a side. Gravity simply feels gentler. The universe is stretching and gravity is letting it. There's no cosmic war, no clashing energies, just a gradual mutual agreement that things are getting spacious. You drift near a cosmic filament, one of the great threads weaving the universe together. Once gravity kept these filaments taut, feeding galaxies along their length like veins delivering nutrients. But now the thread sags slightly like a rope bridge weathered by time. The galaxies along it still shuffle matter between them, but with less urgency, less turbulence. The cosmic web is easing into relaxation mode. You smile at the absurdity of it, billions of light years of structure, all built by gravity now reclining like it finally discovered a hammock. And you suspended in this slow cosmic drift feel your own grip loosen too. Worries expand like space thinning, stretching, becoming lighter. You let them drift the way galaxies drift gently, naturally, without force. The universe is slowing its breath. You inhale, you exhale. The expansion feels less like a race and more like a surrender, and you drift forward ready for where that softness leads you next. You drift farther into the widening hush between galaxies, and something subtle but unmistakable begins to glow beneath the silence. An invisible pressure, gentle yet persistent, pushing everything apart with the determination of someone nudging a sleeping cat off their lap so they can finally stand up. This is dark energy, the laziest force in the universe, and somehow the one running the whole operation. You don't see dark energy. You don't feel it brushing against your imagination like starlight or dust. What you feel is its mood, its vibe. If gravity is the universe's old loyal friend trying to keep everyone together for a group photo, dark energy is the quiet stranger at the edge of the party subtly whispering, "Hey, maybe we should all head home," separately, and the universe, for reasons still unfolding, listens. You drift into a region between galaxy clusters once tightly knit, now gently drifting. The distances between them widen not because they want space, but because space itself insists on giving it to them. Dark energy is like a background process on the cosmic operating system, constantly expanding storage whether anyone needs it or not. Here's your mainstream scientist-backed fact: dark energy makes up roughly 68% of the universe's total energy content, and it's responsible for accelerating cosmic expansion. Not just expansion, accelerated expansion. The universe isn't just stretching, it's stretching faster over time, but that acceleration doesn't feel like speeding. It feels like a long, slow push that grows slightly stronger with every cosmic breath. A lazy push. Like someone rearranging furniture at 0.001 centimeters per year. You float through this quiet acceleration, and it's almost funny how unimpressive it feels. Scientists measure it with supernovae and redshift graphs and clever math. But you experience it as the universe's subtle insistence on more elbow room. No explosions, no fanfare, just cosmic chill. And yet here comes the open debate. Scientists still argue whether dark energy is a constant like a cosmic setting someone forgot to turn off, or if it changes over time. Does it grow stronger, weaker? Does it fluctuate like the mood of an undercaffeinated graduate student? Nobody knows. Observations lean one way, theories lean another, and the conversation floats with you like a low-gravity balloon drifting in a hallway. Some models propose phantom energy, a hypothetical version of dark energy that increases so aggressively it eventually tears apart galaxies, solar systems, atoms, even space-time itself. It's called the Big Rip. And while most physicists don't lose sleep over it, the name alone sounds like a cosmic horror movie that premieres at 3 a.m. on a channel you don't remember subscribing to. But right now, the universe feels nothing like ripping. It feels like reclining. You drift past a galaxy that seems to lean back as space expands underneath it. Its stars orbit lazily, its gas clouds swirl gently, and though it doesn't know it, dark energy is pushing the space between this galaxy and its neighbours ever so slightly wider, like a slow tide rising beneath a busy pier. This is where the quirky fringe idea of the section strolls in uninvited but interesting. Some people speculate that dark energy might be the collective output of countless microscopic universes popping in and out of existence, tiny bubbles flickering like static. According to this idea, our universe is being pushed outward by the constant birth and death of these little quantum universes in the vacuum. It's unsupported by data, but it's cosmic popcorn fun to imagine. You drift through this hypothetical foam, even though no such foam has ever been observed. But the idea lets your mind paint pictures, and those pictures help you relax deeper into the universe's quiet expansion. A star cluster appears in the distance, small, faint, slowly drifting away. You reach out mentally and the distance stretches a tiny bit more. You're not losing it. Space is gaining it. Everything in the universe is slowly becoming more isolated, more local, more private. Not in a sad way. More like the universe is an introvert finally admitting it's happier with a bit more personal space. As you float through this expanding void, you feel how dark energy works best when nobody's paying attention. It's not loud, it's not dramatic, it's like dust accumulating in a quiet corner, imperceptible day to day, but undeniable when you step back and look. And the cosmic joke here? The more space the universe has, the more room dark energy gets to do its thing. Expansion creates space, but dark energy likes space. The relationship feeds itself. It's the ultimate self-reinforcing laziness loop. Scientists still debate what dark energy actually is: a property of space, a field, a misunderstood measurement, a glitch in our equations. Whatever it is, you feel it here as a soft cosmic nudge. No alarms, no urgency, just a steady suggestion that everything should drift gently apart. You inhale, you exhale, and you match the rhythm of a universe that's growing, yes, but growing like someone stretching under warm blankets. Slowly, drowsily, with no need for precision or rush. You continue drifting, and the push of dark energy feels less like a force and more like a mood, a cosmic shrug, and under that shrug galaxies slide away from one another like sleepy icebergs in a warm tide. You glide with them weightless, unhurried, supported by the invisible drift that guides everything. The universe is expanding, yes. But tonight it's expanding lazily, and you drift on. You float forward into a part of the universe where the emptiness grows so delicate, so thin, that matter itself begins to feel optional, like sprinkles on a cupcake no one asked for. Particles, those tiny overachievers that once crowded every nook of the cosmos, now drift so far apart that you could metaphorically swing your arms in any direction for light years and hit nothing but chilled vacuum. And as you ease deeper into this soft quiet, you start to feel the thinning of matter, the way you might notice the fading hum of a refrigerator at night. It happens slowly, then suddenly you realize the silence has taken over. This is where the universe reveals another subtle shift in personality. When it was young, matter didn't just exist, it crowded, pushing and colliding, linking arms, forming stars and planets, out of sheer busyness. Now, though matter has mellowed out, it spreads itself thin like butter scraped over too much cosmic toast. Hydrogen atoms, the universe's favourite minimalists, sit in volumes so vast you'd need 1 billion years just to bump into one more. Here's your solid scientist-approved fact. The average density of matter in the universe today is roughly 1 proton per cubic metre, and across most of space the density is even lower. That means that almost everything, the galaxy, stars, planets, all the things that sparkle on sci-fi posters, make up a hilariously tiny fraction of cosmic real estate. You glide through these increasingly spacious patches and feel the emptiness not as loneliness, but as softness, like a room where someone has taken out all the furniture and let the air expand. Everything feels lighter, looser, less committed to interacting. And this makes sense. When matter spreads out, it collides less. It evolves slower. The universe, in a very real sense, becomes lazy at the atomic level. But scientists still argue whether this thinning out points to a long-term cosmic trend, or if pockets of dense matter will continue forming in locally active regions. Maybe some areas will cling to complexity while the rest drifts into minimalist design. The debate floats with you like dust motes in a sunbeam. You drift by a loose cloud of hydrogen, once the raw fuel for stars, now drifting like forgotten confetti after a parade. These atoms barely hold on to each other anymore. Gravity tries to pull them inward, but the expansion of space keeps nudging them apart, like someone telling two shy strangers to respect personal boundaries. You pass through the cloud and it's so diffuse that you don't even feel a difference. It's like walking through perfume hours after someone sprayed it, just a ghost of what it once was. A quirky fringe idea sidles in here, as they often do. Some theorists, not mainstream ones, propose that matter might be dissipating not just across space, but between universes. According to them, protons could occasionally slip into higher dimensions, thinning out our universe like a leaky faucet in a multiverse kitchen. There's zero solid evidence for this, but imagining protons falling through cosmic cracks is the kind of late-night philosophy that feels appropriate while drifting through ultra-low density space. You smile at the thought and continue gliding. Ahead of you, a galaxy drifts into view, not one of the big bright spirals you know from glossy telescope photos, but a faint, puffy, low-surface brightness galaxy. These diffuse galaxies are barely held together. Their stars are far apart, their gas clouds thin, their structure fragile. They look like galaxies that just didn't have the energy to be more ambitious. You float through its outskirts, where the density drops from very low, so you have a better chance of finding your remote under the couch. Inside such galaxies, star formation slows dramatically. Gas clouds can't collide enough to ignite new stars. The old stars keep burning, but fewer siblings join them. The galaxy becomes a quiet retirement home for ancient suns. You pass by one such star, an old orange giant breathing its last slow breaths. It pulses gently like a nightlight dimming. The matter around it grows thin dust, drifting away at a lazy crawl. Space will absorb this dust into its endless spread, thinning it even further. Scientists still argue how long these slow-motion processes will continue. Will star formation someday stop entirely across the cosmos? Will matter thin out so much that new structures simply cease to appear? Some models say yes, others point to pockets of matter that still cling tightly, still forming stars at respectable rates. Whichever wins, you feel the drift. The deeper you go, the more you feel how the thinning of matter shapes the universe's personality. Everything becomes more spacious, more distributed, more stretched. Interactions grow rare, chaos grows calm, energy dilutes, heat fades, even gravitational clumping becomes less effective. And through all of this, you drift like a dandelion seed floating through an empty field at dusk. You're carried by the thinning itself. Every breath of the universe, every push of expansion, every moment of cosmic diluting feels like a hand on your back telling you, relax. There's more room now, more quiet, more softness. You move between particles that haven't met in millions of years. You wave at a lonely hydrogen atom again, not the same one as earlier though. For how sparse things are, you could almost pretend it is. You glide past a little wisp of molecular hydrogen, proud to be one of the rare places where two atoms decided to hold hands. It's adorable in a cosmic kind of way. Matter thins, space expands, the universe relaxes, and you drift with it, letting the distances widen, letting the particles spread into philosophical solitude. Everything is softer here, everything is slower, and everything is getting just a little bit lazier. You drift onward into a peaceful region of the universe where galaxies no longer roar toward each other like reckless teenagers on cosmic highways. Instead, they slide past you with the languid grace of lanterns floating down a calm river at dusk, soft, slow, unhurried. You watch them drift as if they've made some silent pact to stop colliding for a while and just vibe. These are galaxies in their late-life mood. No more frantic mergers, no more gravitational wrestling matches. Just quiet motion through an ever-expanding sea of space. You reach out again metaphorically, since space is famously bad at returning handshakes, and the nearest galaxy responds not by rushing closer, but by drifting a tiny fraction farther away. It doesn't mean to. It's just riding the expansion like a raft on a gently rising tide. In the early universe, galaxies collided all the time. They slammed together in fiery, chaotic encounters that knitted stars and stretched gas into new shapes. But now you watch them move as if they're tired of all that drama. The distances between clusters widen like someone slowly opening a doorway. Nobody slams anything. Nobody hurries. The cosmic dance becomes more like a slow waltz in a room built to be larger every day. Here's your scientist-approved fact: most galaxies we can see are actually moving away from us, because space is expanding between us and them, not because they're speeding themselves through space. It's the fabric itself doing the work. The galaxies are like little stickers on a balloon being gently blown up. You float deeper into this calm river of drifting galaxies. Their colours fade slowly as they recede, reds, becoming redder blues, becoming a memory. The universe is turning up the chill filter on everything. But scientists still argue whether galaxy collisions will truly fade to near zero in the distant future, or if gravitationally bound clusters like our local group will continue merging despite expansion. Some say the Milky Way and Andromeda's upcoming collision is one of the last great fireworks shows. Others think small groups may keep interacting for trillions of years long after the big cosmic structure has thinned. The arguments ripple around you like muted cosmic gossip. You drift past a pair of dwarf galaxies lazily orbiting each other. They look like two elderly dance partners who've forgotten the steps but still sway because it feels nice. Their orbits stretch out slowly as space expands underneath them. You're close enough now to notice the faint glow of star formation, in one just a few new stars popping into existence, with the enthusiasm of someone who shows up late to a party, but insists on having a good time anyway. Here comes the quirky fringe idea. Some folks propose that galaxies might feel the expansion like a physical wind, not in the sense of air-blowing space is aggressively anti-air, but in the sense that galaxy halos might stretch like taffy under the pressure of accelerating expansion. It's fun to imagine a galactic breeze tousling spiral arms like cosmic hair, even though standard physics frowns deeply at the idea. You smile at the thought because why not? It's late. You're drifting. No astrophysicist is here to scold you. Ahead you see a large galaxy cluster, once a buzzing metropolis of collisions and interactions. Now it looks more like a quiet retirement community. The galaxies still orbit a common centre, but they do it slowly, drifting like tired carousel horses on the world's most relaxed carnival ride. Many of the cluster's galaxies have lost their gas long ago, leaving only old stars behind. They glow with soft yellow light, the universe's equivalent of warm living room lamps. You glide into one of those gently drifting galaxies. The edges are faint and fuzzy, like someone smudged the starlight with their thumb. A few stars linger far from the centre, taking their sweet time completing their orbits. Some even drift so far that the galaxy's gravity barely keeps them. They're like students who left campus but still check their email. As you drift through these outskirts, you feel how isolated everything is becoming. Not sad isolated, more like peaceful solitude. If the universe were a city, this would be the quiet residential street far from downtown. No honking, no crowds, just the slow hum of existence. Scientists still argue how many galaxies will remain visible to observers trillions of years from now. Expansion will push most of them beyond the cosmic horizon, making them fade from detectability. Future astronomers, if astronomer is still a job title, might live in a universe where only their local cluster is visible, the rest swallowed into a dark distance. The debate around this feels like trying to predict what museums will be popular in the year 10 trillion, but it floats with you anyway. You glide past a lenticular galaxy, a halfway spiral, halfway elliptical shape that looks like it couldn't decide what mood it was in. It's smooth, calm, and looks like the kind of galaxy that would own a hammock. Its stars drift in unison, quietly circling like sleepy fireflies. You move on, following the gentle drift of galaxies like lanterns pulled by an unseen current. Their motion is not chaotic like it once was. It's rhythmical, predictable, soft, and you realize the universe's expansion hasn't just slowed the chaos, it has softened the entire cosmic choreography. Everything drifts with less urgency, less collision, less noise, just slower lanterns on a widening river, and you drift with them, feeling the gentle tug of cosmic laziness, pulling you farther into the hush. You drift deeper into the river of drifting galaxies, until the universe grows dim enough that the starlight around you begins to feel stretched, literally, stretched like someone gently tugging at the edges of a glowing bed sheet. Colours fade. Blues soften to whites drift into yellow, and yellows slip into deep sleepy reds. Even the reds after a long journey start wandering into wavelengths you can't quite picture anymore. Starlight stops looking energetic and begins to look tired. You're watching the universe's light grow old. This is redshift, the subtle but relentless stretching of photons as space itself expands beneath them. You glide through beams of light that set out millions, sometimes billions of years ago, bright and punchy like cosmic neon. Now those same photons arrive with their energy diluted, mellowed, softened like voices muffled through walls. It feels like watching fireworks in reverse. Every spark becomes dimmer and slower. Here's your mainstream scientist-approved fact as space expands, photon wavelengths stretch, causing their energy to drop. That's why incredibly distant galaxies look redder. They're literally losing the shortness of their waves to the cosmic stretching underneath them. It's not the galaxy's fault. It's the universe's lazy expansion giving light an unrequested makeover. You drift through a stream of stretched light, and it feels like moving through cool syrup, smooth, slow, soothing. You can almost hear the photons sighing as if they've been travelling way too long and could really use a cosmic nap. But scientists still argue about the deeper interpretation of redshift. Is it purely due to expansion, or is there some subtle effect of space-time curvature we haven't fully understood yet? A tiny minority once proposed tired light, the idea that photons simply lose energy over distance like marathon runners fading at mile 22. Mainstream physics doesn't support this, of course, but the fringe idea floats around like an urban legend the cosmos refuses to delete. You pass a long, thin beam of ancient starlight from a galaxy so distant that its blue stars now appear as a faint pink smudge. That galaxy still shines fiercely in its own neighbourhood, but for you drifting in this quiet expansion, its fire has been stretched into a softer glow. It's like listening to a once loud concert echoing from miles away. The energy is still there, just wrapped in time. Ahead, a quasar flickers once the brightest lighthouses in the cosmos. Now its ferocious ultraviolet blaze arrives to you as a gentle infrared ripple, the cosmic equivalent of using watercolour to remember a bonfire. Even the universe's wildest light engines mellow out over distance. It's strange the way stretching light alters your sense of time. Every photon is a story, and as they stretch, the stories slow. You drift through light that left its source when trilobites crawled along Earth's seafloor. You drift through light older than the Earth itself, older than stars we take for granted. To these photons, everything you know, civilizations, languages, pets, embarrassing texts, is a blink. You glide onward as starlight thins and a quirky fringe idea pops in right on schedule. Some theorists imagine that redshift might encode hidden information, subtle patterns that could reveal past cosmic cycles, or even if you stretch your imagination far enough, signals from advanced civilizations using redshift as a communication medium. It's not supported by data, but it's the kind of idea that shows up at 2 a.m, like a friend whispering, "Hear me out," while pouring another cup of tea. You smile at the absurdity because it's soothing. This whole journey is soothing. Like getting lazier is the universe's ASMR, and you're in the perfect place to listen. You move through the outskirts of a galaxy cluster, and the faint glow from its farthest stars looks like embers scattered on a dark blanket. The most distant of them shed bright blue photons that left before humans existed. By the time those photons reach you, they're stretched into gentle red tones. Starlight ages the way stories do, longer, softer, deeper. Scientists still argue how far this trend can go. Will redshift eventually stretch all visible light into radio waves? Will the universe expand so much that future observers billions or trillions of years from now will see nothing beyond their local cluster, because everything else has redshifted out of detectability? The debate flows around you like slowly drifting thought bubbles. You drift near a star whose light took a mere thousands of years to reach you practically next door in cosmic terms. Its light is crisp, immediate sharp. It looks young. You can almost feel the difference the way nearby starlight crackles while ancient starlight glides. Light carries time in its wavelength. You can sense which photons have had long journeys and which ones are fresh off the press. Farther ahead you see a faint arc of galaxy light that has stretched so much it's on the edge of vanishing. The expansion has taken its original blue-white blaze and stretched it into a reddish whisper. It glows like the final ember in a fire pit that's almost gone out. That ember still tells a story, it just takes patience to hear it. You reach out with your imagination and let that faint light pass over your fingertips. It warms you, not in temperature, but in the quiet truth it carries. Everything bright moves towards softness. Everything loud becomes gentle. Everything energetic eventually slides into calm. Here, drifting through red-shifted starlight, you feel the universe becoming more and more like a lullaby rather than a song. Even the photons, those eternally busy travelers, eventually slow their rhythm, stretch their wavelengths, surrender their sharpness. The universe is expanding lazily, and even light is getting sleepy. You drift forward, letting the stretched starlight fade behind you, until you begin to sense something even stranger. Time itself feels different out here, softer, more flexible. As if the universe, already lazy about stretching space, decided to loosen the rules of time as well, letting moments glide instead of tick. You feel it around you, not as a ticking clock, but as a slow, drifting current you can float through like warm, gentle water. Time has always been a cooperative thing for you. On Earth it moves with predictable rhythms, seconds, minutes, deadlines, alarms. But out here, far from gravity wells and spinning planets, time becomes something less strict. Something that doesn't care about your calendars, or the fact that you once missed your dentist appointment by 3 months. Here's your solid, scientist-approved fact: time does pass differently depending on your speed and gravitational environment. Near massive objects like black holes, it slows down. In emptier space, where gravity barely whispers, time flows a little more freely, a little more lazily. This is relativity doing its thing. Einstein standing in the background with sunglasses nodding like, "Yeah, I told you so." You float through a region of especially thin space, no nearby stars, no heavy gravity, nothing tugging hard on spacetime's fabric. Time here feels stretched, like taffy pulled between galaxies. Seconds feel longer, breaths feel deeper, thoughts feel slower. It's as if the universe is inviting you to stop rushing, to let go of your frantic Earth-time metabolism and adopt a cosmic version of island time. Scientists still argue how to interpret time dilation in extreme cosmic expansion. Does space-time stretching actually slow the internal rhythm of the universe, or does it just change how we perceive distant events? Is time something the universe experiences, or only something we measure? The debates swirl around you like lazy cosmic tumbleweeds. Ahead, you drift close to a galaxy cluster massive enough to bend, light bend, time bend your sense of cause and effect for a moment. It's gentle though. You glide over the edge of the cluster's gravity well like a feather on a warm-up draft, and you feel minutes tighten a little, just a little, as if the air grew thicker even though there's no air here at all. You pull away and time loosens again. It's subtle, but you feel it. The universe is a quilt of slow zones and slower zones. Nothing is fast out here. Nothing is hurried. You look toward a distant galaxy, and as its light reaches, you already redshifted into sleepy wavelengths. It carries another curiosity, that galaxies now is ancient compared to your now. You're watching events that unfolded millions or billions of years ago. From your perspective, the universe is a museum playing reruns. Every photon is a historical document. nothing you see is happening live. A quirky fringe idea pops in right on cue. Some folks speculate that what we see as time dilation is actually the universe processing information at different speeds in different regions, almost like cosmic computers running at varied clock rates. The idea has no mainstream traction, but imagining gigaparsecs of slow processors and fast processors adds a strange charm to your drifting. You continue gliding, passing through space that's so empty, your brain tries to fill the silence with old Earth habits, check the time, wonder what's next, feel the urge to hurry. But the universe doesn't hurry. Not anymore. Even the expansion, though accelerating, feels like a gentle slope rather than a rush, like a moving walkway travelling at 1 molecule per century. You drift into a region where 2 galaxy filaments once intersected. They're farther apart now, so far apart that their gravitational handshake is more of a faint wave across an ocean. The void between them has grown, and you can feel time stretching in that void, like a sigh that lasts thousands of years. Scientists still argue how time will behave in a far future universe where dark energy dominates completely. Will time remain meaningful when no new interactions happen, when matter thins and stars fade? Some think time might flatten, losing its direction. Others think time will simply keep drifting, even if nothing interesting is left to happen in it. Time is stubborn like that. You drift near an ancient star on the outskirts of a galaxy. Pulses rhythmically, each pulse a heartbeat, measured in thousands of Earth years. Time to that star feels different. Its fusion reactions proceed slowly, its internal processes glacial, its orbit around the galactic center leisurely. If the star could talk, it would probably say, "Relax." What's your rush? You glide on, imagining yourself slipping through layers of slow zones like sliding through warm sheets. Here time is not a ruler, it's a blanket. It wraps you, it reassures you. It says everything takes the time it takes. You picture your own life, emails, alarms, deadlines, footsteps on pavement, shrinking into tiny frantic blips compared to the cosmic pacing around you. And instead of making you feel small, it makes you feel relieved. The universe's schedule is infinite. Yours doesn't have to be. You let go, you breathe, you fall into step with the universe's drifting rhythm, and time becomes a companion rather than a taskmaster. You drift on. You drift onward deeper into the universe's quiet architecture until something vast and delicate rises around you, like the silhouette of a cosmic spiderweb. Only this web isn't woven from silk, it's woven from galaxies. Filaments stretch across unimaginable distances, threads made of star clusters and dark matter braided together, forming the scaffolding of everything the universe ever bothered to build. And here, drifting at the edge of one of these filaments, you can feel it sagging, gently, slowly, like a hammock that's held too many lazy afternoons. This is the cosmic web, the grand design left behind by gravity during its energetic youth. Gigantic ropes of matter once pulled tight between galaxy clusters. But now, as expansion continues and everything grows lazier, those ropes loosen. What once looked like the tensile structure of a mighty suspension bridge now feels more like strands of hair drifting in water. Your scientist-approved fact lands right here. The cosmic web formed from tiny density fluctuations in the early universe regions, just slightly denser than their surroundings. Gravity amplified these differences, creating filaments, nodes, and voids. Over billions of years, galaxies flowed along these filaments like beads sliding down thin strings into massive galaxy clusters. But now those strings are being stretched by expansion, not snapped, just pulled, thinned, softened. You glide closer and notice small galaxies migrating along a filament, moving slower than their ancient ancestors did. The gravitational pull that once funneled matter efficiently along the filaments has weakened in the face of dark energy's subtle push. The result traffic is light, movement is gentle. Cosmic logistics have entered their after-dinner lethargy phase. Scientists still argue whether these filaments will continue to stretch indefinitely, or whether local gravitational binding will keep some segments intact. Some simulations predict that the cosmic web will one day fracture into isolated islands of matter, each drifting through the expanding ocean alone. Others argue the filaments are strong enough to remain connected for trillions of years. As always, the universe refuses to clarify the matter. You push through the center of a filament, if pushing is even the right word for drifting through something so soft and sparse. Galaxies cluster loosely around you like glowing beads adrift in an enormous cosmic scarf. their light blends into the faintest haze. You can tell these galaxies once interacted more actively, colliding, merging, exchanging gas like rowdy neighbours in a tightly packed apartment block. Now they feel like suburban houses, spaced comfortably apart, waving from afar. And here comes your quirky fringe idea, strolling in, with the casual confidence of a theory that knows it's speculative. Some cosmologists have toyed with the possibility that the cosmic web resembles the neural structure of the brain, not just visually, but functionally. According to this poetic speculation, maybe the universe processes information through these filaments. Maybe consciousness or something like it isn't an Earth-exclusive glitch, but a large-scale property. Mainstream scientists raise an eyebrow at this, but the idea has an undeniable charm at 2 a.m. You look at the filaments in front of you, branching, reconnecting, thinning. Yeah, you can kind of see it. If space could think, you imagine it would think slow, measured thoughts, each one taking millions of years to form. Not exactly great for replying to text on time, but fantastic for cosmic meditation. Ahead, the filament bends, slightly sagging under its own vastness. Dark matter, the invisible skeleton holding this structure together, still does its work, but even dark matter feels more like a mellow guide than a strict architect now. The halo shapes are softer, the potential wells shallower. Everything feels less rigid. You drift along a filament until you reach a crossing a node where multiple filaments once converged with gravitational enthusiasm. Now the convergence is calmer. Galaxies swirl slowly like leaves circling a quiet eddy in a wide river. Their orbits don't have the fierce energy they used to. Instead, they drift with a rhythm that feels almost sleepy. You hover there for a while, watching the slow-motion ballet. Stars drift. Gas clouds wander. The entire structure seems to exhale. Scientists still argue how the cosmic web will evolve hundreds of billions of years from now. Will filaments evaporate into thin, lonely streams? Will nodes shrink until they contain only a few surviving galaxies? Or will the web's skeleton persist, even as the spaces between grow so large that light itself struggles to navigate it? The future is uncertain, even for structures this big. You lean gently into a turn in the filament, letting it guide your drift like a soft cosmic slide. You feel how space stretches underneath, pulling the filament thinner and thinner. It doesn't resist. It yields like someone relaxing into a yoga pose after centuries of stubbornness. You glide onward past galaxies so faint they resemble smudges, past wavy textures of dark matter that you can only sense, not see, past voids whose emptiness feels like a soft sigh more than a harsh silence. And as you drift, you realize you're watching the universe's bones grow easy. The structure that once held everything tightly is relaxing, loosening, settling into cosmic comfort. Just like the rest of the universe, just like you. You drift out of the sagging filaments of the cosmic web and into a darker, more mysterious territory, an area where gravity becomes a whisper, and the most powerful objects in the universe begin to feel strangely detached. You're entering the domain of black holes, but not the dramatic, snarling, light-eating monsters from sci-fi posters. No, these black holes feel different now. Relaxed, quiet, almost meditative, like old warriors who've set down their weapons and decided to watch the cosmos from a shady porch. You hover near one, an enormous, supermassive black hole at the center of a lonely galaxy. Once upon a time it ruled this place. It consumed gas clouds, devoured stars, fired jets of plasma across light years, and wrapped space-time around itself with the enthusiasm of a cosmic wrestler. Now it sits there in near-perfect stillness, like a giant that just woke up from a millennia-long nap and isn't sure it wants to get out of bed. Here's your mainstream scientist-approved fact. Black holes don't pull harder because of cosmic expansion. In fact, their influence is strictly local. Gravity remains strong nearby, but expansion pulls the larger-scale universe apart in ways black holes can't fight. They're like powerful anchors in a sea whose tides are rising everywhere except right at their feet. Close in their grip is absolute. Farther out, the universe simply moves on. You float near the event horizon, watching light bend around it with the gentle flow of honey. No urgency, no frenzy, just smooth curvature. In this far future quietness, even the accretion disk, if one was ever there, is gone. The black hole is starving. Not dangerously, just lazily, like someone skipping meals because the fridge is too far away. Scientists still argue whether isolated black holes will eventually evaporate entirely through Hawking radiation, Some say yes, given enough time they slowly leak energy until they vanish in a faint puff of quantum light. Others propose exotic possibilities that black holes might stabilize at a minimum size or turn into wormholes, or leave behind some kind of remnant the universe carries like a fossil. The debate drifts around you like distant static. You drift closer, allowing gravity to nudge your imagination. Time slows near the event horizon, stretching moments out like a cosmic taffy puller. You're not falling in, just hovering close enough to feel the distortion. Seconds feel wider, minutes feel longer. Your thoughts stretch like shadows in the late evening sun. This close, you sense something profound. The universe is expanding everywhere except here. The black hole doesn't grow weaker. It doesn't get pulled apart. It just becomes lonely. Everything it could once feed on has drifted beyond reach. Galaxies are moving away. Gas is thinning. Stars are fewer. The cosmic buffet is closing. And that's when the quirky fringe idea of this section strolls into view. A few theorists, not mainstream ones, suggest that black holes might be gateways to baby universes. That every black hole is a womb, where new space-time bubbles form budding off like cosmic seeds. They claim our universe might even be the inside of some parent black hole. Is this supported by standard physics? Not really. Does it make your imagination stretch in delightful ways? Absolutely. You drift around the black hole's equator, watching the faint gravitational lensing of distant starlight curve into arcs. It looks like the universe is being reflected in a funhouse mirror, warped, softened, gently distorted. You sense how powerful this object remains, even as the wider cosmos relaxes. Like a sleeping dragon who still radiates heat. You pull back slowly, feeling gravity loosen its grip. As you drift outward, time regains its usual flow. You look at the galaxy surrounding the black hole and it feels empty. Not dead, just minimal, faded. A few old stars orbit lazily red giants, glowing like embers scattered across a cooling hearth. Scientists still argue how long supermassive black holes will persist before the universe becomes too thin to sustain them. Some models say trillions of years. Others say they might outlast stars, galaxies, and everything but the faint ghost of expansion. If the universe eventually becomes dominated by dark energy, black holes might be the last interesting structures standing cosmic anchors in an ocean of near nothing. You drift farther, noticing smaller black holes once formed from collapsed stars wandering without purpose. They move like tired wolves in an ever-expanding forest. No prey, no pack, just wandering occasionally tugged by passing debris, but mostly alone. You feel a strange emotion, rise sympathy. But then you remember they're literally space-time pinholes of infinite density, so maybe they don't need sympathy. Still, there's something undeniably quiet about them, something patient, something deeply aligned with the universe's lazy expansion. A rogue star drifts past one such black hole. Not falling in, just passing by. Long ago, stars like that would have spiraled inward, feeding the black hole, lighting up its surroundings. Now the distance is too great, the chance too small. The star and black hole exchange a slow, gravitational nod like passing strangers, and continue on their separate paths. You drift on, leaving behind these cosmic giants. And as the last curved shimmer of lensing fades from view, you recognize a new truth settling into the universe. Even the strongest things are becoming gentle. Even the hungriest things are becoming patient. Even the most violent things are becoming quiet. And you drift with that softness. You drift away from the quiet giants, the black holes lounging like cosmic retirees, and move into a region of space where the universe's oldest ingredients still linger like forgotten spices in a cupboard. Hydrogen, helium, a sprinkle of lithium, the lightest elements, the firstborn children of the cosmos, drifting through the darkness with a kind of nostalgic serenity. And as you glide through them, you begin to feel how much these simple atoms shaped everything, back when the universe still had energy for drama. This is the era of lighter elements, the primordial chemistry set from which everything else eventually bloomed. And here's your scientist-approved fact. Most of the hydrogen and helium in the universe was formed just minutes after the Big Bang during a brief period called Big Bang nuclear synthesis. Within the first 20 minutes of existence, the universe decided the bulk of its chemical budget and never really revisited the topic. You drift through a cloud of mostly hydrogen, those chill one-proton atoms that refuse to be anything other than themselves. They float with the relaxed attitude of early retirees who've decided work is overrated. Helium atoms join them, each boasting 2 protons like show-offs who peaked early. Lithium. Well, Lithium is that shy friend who didn't quite get the memo and only shows up in tiny amounts. You glide deeper into these clouds and sense how different everything once was. These atoms used to move fast, really fast, slamming together in the hot, dense youth of the universe. Back then it was all energy and collisions, like the world's loudest crowd at the world's smallest concert venue. But now the gas has cooled, slowed and stretched. Collisions happen so rarely that you could float through this cloud for light years without bumping into anything. Scientists still argue about subtle details in Big Bang nucleosynthesis, like the mysterious mismatch between predicted and observed lithium levels. It's called the cosmological lithium problem, and it's one of those disagreements that keeps cosmologists up at night staring into cups of cold coffee and muttering, "Where is the lithium hiding?" No one knows. The debate drifts with you like a loose helium balloon no one remembered to tie down. You move into a slightly denser region, dense by cosmic standards, which still means emptier than your average living room after everyone has gone home. Here, hydrogen atoms occasionally find each other and form H2, the universe's coziest molecule. You pass through a few such clusters and they feel warm. Not in temperature, but in mood, like little cosmic friendships, the fun part. These simple molecules are still the backbone of star formation today, but star formation has slowed dramatically, because even these light elements have spread so thin that they rarely clump strongly enough to ignite. You sense that fading spark. The universe is still capable of creating stars, but it does so with the gradual patience of someone knitting by candlelight. A quirky fringe idea drifts in like a cosmic daydream. Some theorists have proposed that the early universe might have created exotic elements that didn't survive into later epochs. Things like heavy but unstable particles that decayed too fast to leave permanent traces. According to them, the light elements might have been the survivors, not the whole story. There's no solid evidence for this, but imagining a chaotic primordial stew full of strange temporary ingredients fills your mind with delightful weirdness. You glide past a region where an old star is shedding its outer layers. The expelled gas, mostly hydrogen and helium, floats away like pastel smoke from a slow-burning incense stick. In the early universe, this gas would have been snapped up quickly, dragged inward, recycled into new generations of stars. Today, the gas disperses gently, drifting apart so lazily you could take 1,000 naps before it clumps into anything useful. Scientists still argue how much longer star formation can continue as these light elements drift apart. Some estimates suggest tens of billions of years before star birth becomes nearly impossible. Others argue it may continue in sporadic bursts long after galaxies fade. The debate glows around you like faint flickering lanterns. You drift into a small pocket of molecular hydrogen where the density is just barely high enough for star formation. Gravity gathers the gas ever so slightly, nothing dramatic, just a slow, shy pull. You watch as atoms drift closer. They don't crash. They approach like polite strangers at a bus stop. Over millions of years, this tiny region may create a star. Or it may not. The universe doesn't rush it. You pass through helium-rich regions, remnants of old red giants. Helium glows gently when heated, but out here it's cold, dark, and so slow-moving that it feels like time itself has lowered its volume. You realize these light elements will outlive stars, galaxies, and possibly even black holes. They float through the widening universe with cosmic patience, waiting for nothing. As you drift on, the clouds grow thinner. Hydrogen atoms become sparse, then extremely sparse, then nearly philosophical, existing more as a suggestion than a presence. You sense the shift. You're leaving the remnants of star-making material behind and moving into regions where matter simply doesn't bother clumping anymore. The light elements ruled the early universe. Their chemistry built everything. Their collisions forged the first stars, planets, black holes, every structure the cosmos ever admired in the mirror. But now they drift with the rest of the universe, softly, slowly, content in their simplicity, and you drift with them, feeling the quiet pride of the first cosmic elements settling into a long, long rest. You drift onward from the ancient hydrogen clouds until a faint warm shimmer appears ahead, like the glow of a distant hearth in an ever-cooling house. It's the light of stars, but not the fiery, overachieving stars of the early universe. These are calmer, steadier, long-lived stars whose lives have stretched far beyond what their ancestors could have imagined. You approach them slowly, and you begin to sense a quiet truth. Even stars are burning slower now. You glide around a dim orange star that feels like it's taking its sweet time with everything. Its nuclear fusion hums softly, steady but unhurried. compared to massive blue giants which lived fast, died young, and threw spectacular tantrums. This star is the cosmic equivalent of a person who chews every bite 30 times because it's good for digestion. And here's your scientist-approved fact: low-mass stars burn hydrogen at an incredibly slow rate, allowing some to live for trillions of years, far longer than the universe's current age. If the universe had a to-do list, these stars would still be working on task number 1. You drift into its warm glow and feel the serenity radiating from its surface. Tiny convection cells bubble up lazily like the slow simmer of a soup made by someone in no hurry to eat. Stars like this red dwarfs dominate the universe. They always have, but now as matter thins and everything drifts apart, their calm endurance feels more meaningful. They're the marathon runners who trained for the long haul while everyone else sprinted and collapsed ages ago. Yet scientists still argue how stable these ultra-long-lived stars truly are. Some claim their magnetic activity cycles might flare unpredictably, even after trillions of years. Others suggest their steady burn could grow patchy as they age. The debate drifts like a sleepy argument between two astrophysicists who both forgot what the original point was. You leave the red dwarf behind and drift toward a star cluster forming at the edges of a galaxy, a rare sight these days. The clouds feeding the cluster are thin, stretched by expansion, reluctant to gather. But somehow they've managed it. Gravity has convinced enough hydrogen and helium to join the party. You watch as one protostar contracts very slowly, like someone settling into a beanbag chair in microgravity. The light it emits flickers gently. The temperature rises at a leisurely pace. Nothing here feels rushed. Even nuclear fusion seems to wait until the last possible moment, as though the star is asking, "Are we sure we want to commit to this?" And then very softly it ignites. You've seen stars form in early universe simulations before chaotic swirls, violent collapses, bursts of radiation. But here in the late-era cosmic calm, starbirth feels more like lighting a candle rather than launching a rocket. The protostar becomes a young red dwarf with a long, slow future ahead. It will outlive entire galaxies. It may even outlive black holes. You drift on, passing a few larger stars, massive relics left over from more active epochs. Their fusion proceeds quickly compared to their younger counterparts. They are the sprinters in a universe that has largely moved on to meditation and gentle stretching. One star you pass has already consumed most of its hydrogen and is slowly transitioning into its helium-burning phase. It swells into a mild red giant, not the dramatic explosion of its ancestors, but a soft expansion like someone inflating a balloon with 3 slow breaths. A quirky fringe idea pops up right about now. Some theorists suggest that, as the universe expands and thins out, fusion itself might subtly change due to shifts in fundamental constants. According to their speculation, stars in the extremely far future might burn even slower or faster, depending on how cosmic expansion affects quantum fields. Mainstream physics is not fully convinced, but the idea floats around like a philosophical doodle on a napkin. You smile at the image of next-generation stars adjusting their fusion rate, like someone fiddling with the dimmer switch of a lamp. As you drift through the outer arms of a quiet galaxy, you notice how star formation has slowed everywhere. Gas clouds are faint, fragile. Collisions are rare. Gravity works gently, now coaxing material instead of wrestling it. The few blue stars you spot burn bright, but brief, a reminder of a more energetic cosmic youth. They stand out like the last fireworks after a long evening, and when they fade, only the red and orange elders will remain. Scientists still argue how the decline in star formation will shape the universe's final eras. Will the cosmic inventory of stars freeze at some number? Will rogue pockets of gas stubbornly continue making stars even after the rest of the cosmos quits the business? Will brown dwarfs, those almost, but not quite stars, become the final flickers of warmth in an otherwise cold expanse no one knows? You glide through a region where old faint stars populate the outskirts. White dwarfs cool, slowly becoming darker with every billion years. They no longer burn. They just remember burning. Their glow is the aftertaste of ancient fusion. You pass one such relic, a quiet white dwarf so old its luminosity has softened into a pale ember. It doesn't crackle, it doesn't flare, it rests. In the far future, white dwarfs like this may cool into black dwarfs, dark cold spheres of carbon and oxygen. But that will take longer than the universe has currently lived. Much longer. You drift past and feel a small human truth rise in your chest. Even the universe's furnaces eventually dim their flames. Everything that burns slows down. Everything that glows eventually softens. Energy disperses. temperature drops. The cosmos itself transitions from fiery passion to gentle warmth. The universe is still making stars, yes, but it's doing so in the slowest, sleepiest way imaginable. And as you drift, feeling the calm glow of these gentle furnaces, you match their pace, breathing slower, thinking softer, drifting deeper into cosmic quiet. You drift away from those slow-burning stars and glide into the soft outskirts of a spiral galaxy where the light is dim and the gas clouds feel like faint perfume clinging to the air long after the person wearing it has left the room. This is where you begin to feel something subtle shift, not in you but in the galaxy itself. The weather of the cosmos, once turbulent and dramatic, is becoming mild, predictable, almost cozy. Cosmic weather isn't wind or rain. Of course, it's the movement of gas, the pressure of radiation, the collapse of clouds, the shockwaves of supernovae, the magnetic tantrums of newborn stars. In the early universe, this weather was absolute chaos. Gas clouds slammed together, triggering wild bursts of star formation. Supernovae detonated every few seconds across the cosmos. Everything was hot, dense, and restless. Now you drift through a galaxy where all of that has calmed down. Most of the dense star-forming gas has been used up or blown apart ages ago. The remaining gas moves with a kind of cosmic reluctance, slow, smooth, unbothered by urgency. Clouds drift like lazy summer clouds on Earth, never colliding hard enough to do anything interesting. Star formation still happens, but it's like watching a campfire that refuses to go out yet only crackles occasionally. Here's your mainstream scientist-approved fact. The star formation rate of galaxies has declined by more than 90% over the last 10 billion years. Galaxies were once wild star factories. Today they're more like quiet workshops making the occasional spark. You glide into a faint nebula, a ghost of what it once was. The gas is thin, almost transparent. Millions of years ago, this region might have birthed hundreds of stars. Now it's drifting apart, too diffuse to ignite anything. You drift right through it. It feels like walking through a patch of warm fog that forgot how to condense. Scientists still argue whether galaxies will experience occasional late-life starbursts, when random collisions or tidal interactions briefly squeeze their gas together. Some models say yes, small flares of activity will continue far into the future. Others argue starbursts are nearly extinct victims of dark energy's expanding influence. It's a quiet debate fitting for the topic. You continue drifting, and soon you sense the difference in galactic weather firsthand. Early galaxies were full of turbulence gas, spiraling inward shockwaves racing across arms, magnetic fields twisting like angry serpents. But now the turbulence has died down. Even the magnetic fields feel weakened, stretched thin by expansion and depleted gas. A quirky fringe idea sneaks in wearing sunglasses and sipping something cosmic. Some theorists have proposed that the decline in galactic weather might allow exotic low-energy structures like cold, molecular lattices or macroscopic quantum states to form in interstellar space. Think giant cosmic snowflakes. Mainstream science isn't buying tickets to that show, but imagining intricate crystal-like structures drifting through the galaxy is too charming to dismiss at this hour of the night. You smile and drift deeper. Ahead you see a once busy region of the galaxy where supernovae used to explode like cosmic popcorn. But the massive stars are nearly gone now. Only a few remain rare, bright and inefficient. The supernova rate has plummeted. In their absence, the galaxy feels quieter, softer. Its chemical kitchen, once constantly stirred by explosive recycling, is slowing down. You move past a region where planetary systems are forming around faint red dwarfs. The dust disks are thin, delicate, barely gravitationally bound. They swirl slowly. Planets form gradually like sediment settling at the bottom of a still pond. Nothing rushes, nothing collides violently. Even the planets being born look like they're taking their time. Scientists still argue how long planetary formation will continue in the universe. Will new planets be born trillions of years from now, or will the dust eventually spread so thin that planets become a rare luxury? Models differ, but all agree the pace is slowing. You drift into the spiral arms. These once dramatic regions have lost most of their gas. The arms are still beautiful, still sweeping, but they've thinned and softened, lost the spark of vigorous star birth. They resemble ancient rivers whose currents have slowed to gentle flow. Even the galaxy's center feels different. The supermassive black hole holds its posture but not its hunger. Without strong inflows of gas, it no longer fuels wild luminosity or jets. The bright quasar days, those cosmic rave parties, are over. What remains is a quiet gravitational elder sitting at the heart of a calm city. Above and around you, everything feels balanced, like the galaxy has become a snow globe where someone has stopped shaking it. A few faint star-forming knots still flicker here and there, little cosmic embers refusing to extinguish. But compared to the galaxy's wild youth, this stage feels peaceful, mature, content. The galaxy isn't dying, it's settling in, a kind of cosmic middle age where intensity softens into warmth. You drift through the outskirts and dive into a dark region of interstellar space. Dust glimmers faintly. Old stars glimmer faintly. Everything whispers. The galaxy's chaotic weather has calmed into something gentle enough to fall asleep to. And as you float through this softened galactic landscape, you feel your own inner weather shift too. Thoughts settle. Tension disperses. The frantic collisions in your mind mellow. You match the galaxy's rhythm, a quiet, steady breathing in and out. The universe is growing calmer, and so are you. You drift onward, leaving behind the softened galactic weather, until the universe around you grows noticeably cooler, not just in temperature but in attitude. Everything feels subdued now, as if the cosmos itself has pulled a thick blanket over its shoulders and decided to settle into a long, slow evening. The faint glow of starlight dims, radiation thins, movement relaxes, and you begin to sense the most fundamental shift of all the cooling of everything. Cosmic cooling isn't sudden. It doesn't swoop in like a cold front. It's the quiet, persistent spreading out of energy as the universe expands. Heat disperses, light stretches, motion slows, and with each passing billion years, the universe becomes a gentler, colder version of its former self. Here's your mainstream scientist approved fact. The average temperature of the universe today is just 2.7 Kelvin, barely above absolute zero. That temperature comes from the cosmic microwave background, the faint afterglow of the Big Bang. And as expansion continues, that temperature keeps dropping. Slowly, steadily, inexorably. You feel this cooling as you glide. Space isn't harsh, it's tender, a cold velvet darkness that wraps around you like the softest shade. It's not the biting cold of winter air. It's the ancient cold of a universe that has spent billions of years letting its energy unwind. Scientists still argue how long this cosmic cooling will continue and how it shapes the universe's distant future. Will everything approach absolute zero? Will quantum effects create a floor temperature? Will the vacuum itself maintain a faint energy that prevents total stillness? The debate hovers like a quiet hum, never loud but always present. You drift through a region where a galaxy once burned brightly. Now the galaxy glows faintly, its stars cooler and older. You pass a red dwarf whose surface temperature is down to its slow-burning minimum. It emits gentle warmth, the cosmic nightlight refusing to turn off. A little farther, you pass a white dwarf that has cooled so much it barely glows. It's on its way to becoming a black dwarf, a hypothetical object that hasn't had time to form yet because the universe isn't old enough. But you can almost imagine its future self a perfectly cold, perfectly dark ember of a long-finished star. The cooling seeps into everything. Gas clouds cool into delicate veils. Molecular motion slows. Even quantum fluctuations seem like they're stretching their metaphysical limbs before bed. And right on cue here comes your quirky fringe idea. A handful of theorists have speculated very poetically that as the universe cools, new forms of ultra-low temperature life could arise. Life built on superconducting networks or condensed matter structures that operate at temperatures near absolute zero. It's not supported by evidence, but the idea has an eerie beauty. Tiny, slow intelligences drifting in the cold, thinking thoughts that take centuries. You imagine them greeting you with a wave so slow it looks like a glacier deciding to be friendly. You smile and drift deeper. Ahead you see a galaxy cluster cooling together, no longer exchanging heat through collisions, no longer energizing each other through radiation. Their islands growing dimmer with each passing epoch. Even the intra-cluster gas, once heated by violent mergers, now cools, gradually settling like warm mist returning to still water. You drift through that cooling gas. It feels layered, ancient, a memory of energetic days long past. If galaxies had nostalgia, this gas would be it. You move on, and the cooling becomes even more obvious. Space is expanding, carrying energy outward like a slow exhale. Photons stretch until they lose their vigor. Heat spreads into infinite nothingness. The universe is becoming thermodynamically polite, no hotspots, no fierce gradients, just a gentle leveling toward uniform cold. Scientists still argue whether dark energy will accelerate this cooling to the point where not even particles interact meaningfully, or whether rare islands of warmth like late-stage stars, lingering black holes, or quantum fluctuations will punctuate the cold with tiny pockets of activity. But tonight, drifting here, you feel the cooling steadily taking hold. You pass a rogue planet, no star, just a lonely world drifting through darkness. Its internal heat leaks away slowly. The glow from its molten core dims. It becomes a cold sphere in a colder void. Yet there's a kind of beauty in its solitude, a perfectly quiet traveller in a perfectly quiet universe. You drift past it, letting the cold wash over your senses. It feels clean, pure, soothing in a way you didn't expect. The cooling continues on every scale. In the galactic suburbs, dust grains radiate away the last traces of small collisions. In empty space, the temperature drops to fractions of a Kelvin below the cosmic average. Even cosmic rays lose their punch over immense distances, becoming little more than faint ripples. And you drift with all of it. You feel your thoughts cooling too, not freezing but slowing, easing, relaxing. Like the universe is gently lowering the brightness knob on everything, including your own mental noise. The universe is not dying, it's not collapsing, it's not panicking, it's cooling, settling, relaxing. The same way a campfire burns bright, then glows, then settles into warm embers that remain beautiful long after the flames fade. You drift into the cooling darkness and breathe not air but the feeling of cosmic calm. Everything that once was hot has become gentle. Everything that once was frantic has become soft, and the universe, growing sleepier by the epoch, invites you to drift with it into deeper quiet. You drift farther into the cooling twilight of the cosmos, until you begin to feel something subtle beneath the darkness, an invisible scaffold, a ghostly architecture that once held galaxies together with fierce determination. It's dark matter. But here in the universe's slower, lazier era, even dark matter feels different, less taut, less urgent, less like a cosmic bouncer at an exclusive club, and more like a tired security guard leaning against the wall, letting the night take care of itself. Dark matter, halos, used to dominate the dance of galaxies. They were the hidden hands shaping rotation curves, pulling stars inward, keeping galaxies from flying apart like badly organized fireworks. But now, as you drift through a faint halo surrounding an ancient galaxy, you sense how the expansion of space has changed the mood. The edges of the halo feel softer, as if gravity's grip has loosened its fingers. Here's your solid, scientist-approved fact: dark matter, halos extend far beyond the visible parts of galaxies, providing the gravitational glue that holds them together. Without these halos, galaxies would spin apart. Yet as the universe expands, these halos become more diffuse, not because they lose mass, but because space itself stretches around them. You glide through one such halo and it feels like drifting through the faintest cool mist. Nothing touches you. Nothing bumps you. It's like being inside a memory rather than a structure. Dark matter doesn't collide. It doesn't clump the way normal matter does. It drifts, coasts, obeys gravity in the quietest way possible. And as the universe grows larger and lazier, the halo stretches, becoming thinner, like a knitted blanket pulled across a giant bed. Scientists still argue about the exact behavior of dark matter in the expanding universe. Does the density profile flatten? Does the halo fade into the background? Does dark energy eventually erode even these gravitational bubbles, leaving only the densest cores behind? The models differ, and the debate rolls gently around you like distant thunder. You drift closer to a galaxy's central region where dark matter density is stronger. Here the gravitational pull still feels firm, like the last tight knot in an otherwise loose rope. Stars circle quietly, held in place by unseen arms. But even here the edges are softening. Dark matter no longer funnels fresh gas toward the center. The flows that once fed star formation have slowed to a trickle. You pull back, drifting into the outer halo again. And that's when the quirky fringe idea of this section strolls in, wearing a lab coat that no one takes seriously. Some theorists speculate that dark matter might not be particles at all, but tiny ripples in space-time, topological defects, cosmic strings, or even primordial black holes. If so, the stretching of the universe might literally stretch the nature of dark matter itself. Mainstream scientists arch an eyebrow at this notion. But it's the kind of wonderfully absurd idea that feels right at home while you're drifting through a universe that's slowly turning into a cosmic spa. You move deeper into a region where the halo thins dramatically. A few lonely stars drift at its edge, orbiting slowly, so slowly it feels like each revolution takes a cosmic deep breath. Gravity here is faint, gentle, more of a suggestion than a command. And yet despite this gentleness, the structure holds. The galaxy remains intact. The halo, though, stretched still, wraps around it like a soft cloak. Scientists still argue whether dark matter halos will eventually freeze into shape as expansion outpaces their ability to contract. Some simulations show halos drifting apart so completely that galaxies become isolated bubbles, each with its own little envelope of dark matter that never interacts with another again. Others suggest dark matter might slowly settle toward the center over trillions of years, creating dense cores long after stars have faded. You drift farther out and the halo becomes so thin you can hardly sense it. The density drops to nearly nothing, and the gravitational pull becomes a whisper, a cosmic whisper that says you're reaching the edge. And then softly you float beyond it. The galaxy behind you shrinks into a warm glow. Its halo becomes invisible. The dark matter that once shaped its destiny now stretches across the cosmos, more philosophical than functional. It once organized galaxies, structured the cosmic web, guided star formation. Now it drifts relaxed, patient, timeless. Ahead of you lies the true emptiness between halos, a void where dark matter density is so low that a single particle might never meet another across the entire lifetime of the universe. And yet even here, dark matter exists, thin, diffuse, wandering through an ever-widening ocean. You glide through this emptiness, sensing the gentle shift from structured gravity to the softer drift of a universe choosing quiet over conflict. Dark matter once fought with baryons to shape everything. Now it simply coexists, drifting through the expansion, like a veteran laying down their armor. You breathe into the quiet. You feel the looseness in the universe mirrored inside you. Rigid structures soften, boundaries stretch. Everything expands into gentler forms. Dark matter is still here. It's just drifting with the rest of us. You drift forward into a region of space-time where everything feels stretched, not broken, not strained, just gently pulled like warm taffy in the hands of a patient confectioner. The galaxies behind you fade into softer points. The dark matter halos stretch into faint ghostly veils. Even the emptiness itself feels like it's been elongated, and you realize you've entered a part of the universe where expansion no longer feels like motion, it feels like texture. This is where cosmic expansion becomes less of a fact and more of a sensation. You don't see space growing, you feel it. A subtle tug, a slow relaxation like an exhaled breath that never fully ends. Here's your mainstream, scientist-approved fact. Space-time expands uniformly, not pushing objects through space, but stretching the space between them. That's why distant galaxies recede faster than closer ones. The space between you and them simply has more stretching room. And the farther away you look, the more dramatic this stretching becomes. You glide forward and imagine the entire cosmos as a sheet of warm taffy being pulled from all sides. Galaxies are the raisins stuck inside it. They're not moving through the taffy, they're just being gently carried apart as the sheet lengthens. But what's strange now in this late-era universe is the speed, or rather the slowness, of how you perceive this stretching. Once expansion felt like a rush, a cosmic sprint set off by the Big Bang and fueled by dark energy's growing push. But now, even though expansion accelerates, the universe feels lazier. The stretching has become so steady, so smooth, so uniform, that it feels less like motion and more like gliding down an endless escalator set to its lowest possible speed. Scientists still argue whether this late-time expansion is truly accelerated in the physical sense, or whether our models will need updating as we gather more precise data. Some suggest the acceleration might change over time. Others propose that dark energy could shift phases, causing expansion to speed up, slow down, or even oscillate in strange rhythms. And you drift right through this uncertainty, feeling none of the urgency behind the equations, just the gentle cosmic pull. Ahead, you see a pair of galaxies stretched across a filament of the cosmic web, moving apart like two lanterns drifting on slowly diverging currents. You watch the space between them stretch, not like rubber snapping, but like cloth gently being smoothed. Their shapes don't distort, their stars don't scatter, they simply grow more distant. a quirky fringe idea slides into your thoughts. Some theorists have suggested that expansion might be the result of quantum fluctuations scaling up like tiny taffy stretching events happening everywhere at once. According to these speculations, the universe is not expanding because of a force, but because space-time likes to create more of itself. It's cosmic boredom as a driving mechanism. Not accepted physics, of course, but wonderfully absurd enough to fit with the universe's increasingly chill demeanor. You drift closer to one of the galaxies. Within its boundaries, expansion has no meaning. Stars orbit just fine. Planets spin normally. Moons tug on tides. Local physics ignores the cosmic stretching entirely. Expansion only matters at the grand scale, the vast distances where gravity's grip weakens and space gets to have its moment. But as you move outward again into the intergalactic spaces, you feel it more clearly. Expansion isn't fast, it's not forceful. It's a slow light pull like a whisper brushing past your ear. It's so gentle that if you tried to measure it within a solar system, you'd come up empty-handed. But across millions of light years, it adds up. And across billions, it becomes the universe's dominant rhythm. You continue drifting, and the feeling of stretched space-time becomes almost tactile. The distances ahead of you seem to lengthen as you approach them, as if the floor of the cosmos is one of those airport moving walkways turned down to 0.01 speed. You're not being carried forward. The walkway is gently sliding backward beneath your feet. Scientists still argue what the far future of this stretching looks like. Will expansion become so intense that galaxies become isolated islands never interacting again? Will the cosmic horizon shrink until only our local group remains visible? Will space-time continue stretching even when matter becomes a rare novelty in an ocean of cold? You drift past a faint ancient star whose light has been stretched deep into the infrared. It flickers with the faintest warmth, and for a brief moment you imagine feeling that warmth on your face. But the light is so stretched, so softened by distance and time that it almost feels like a memory rather than a glow. Ahead, a rogue nebula stretched thin by expansion wisps out like smoke disappearing into wind. Its filaments are long, fragile, barely holding together. Once dense and vibrant, it is now a translucent shadow of its former self. Expansion hasn't ripped it apart, it has thinned it the way fog thins in the morning sun. You drift on, and the stretching grows more philosophical. You realize that expansion is less about pushing and more about allowing. Allowing things to drift to separate, to soften, to ease. The universe isn't racing outward, it's relaxing outward. Like taffy pulled by gentle, patient hands. Like a long breath. Like the quiet widening of space between thoughts as you fall into sleep. And as you glide through this stretched, softened space-time, the universe's gentle laziness becomes your own. The tension inside you stretches, the tightness loosens, everything lengthens into calm, the universe expands, and you relax with it. You drift onward into a region of the universe where the pace of life, cosmic life, has mellowed into a gentle, almost sleepy rhythm. Stars burn slower, gas clouds wander lazily, and ahead of you, like glowing islands scattered across an endless sea, you begin to see the true characters of this late-time cosmos, small dwarf galaxies and enormous elliptical giants drifting in a slow-motion dance that feels less like evolution and more like an after-hours sway at the universe's quietest ballroom. This is where you feel the contrast between the tiniest galaxies and the titans most starkly. Dwarf galaxies flicker like candle flames, delicate light faint. Giant galaxies glow like dim chandeliers, broad, heavy, majestic in their half-sleep. And all of them move with a gentleness that suggests they no longer have anywhere urgent to be. Here's your mainstream scientist-approved fact: dwarf galaxies are the most common galaxies in the universe, far outnumbering the big spirals and giant ellipticals. They're also incredibly long-lived, often retaining their gas and forming stars in slow, steady trickles. Giant galaxies, on the other hand, burned through most of their star-forming fuel long ago, becoming vast, calm reservoirs of ancient red stars. You drift toward a dwarf galaxy first. It looks fragile, like a puff of cosmic dust held loosely together by gravity's final threads. But up close, it's more resilient than it seems. Its stars orbit with quiet determination. Its pockets of gas swirl slowly, forming a new star only once every few million years. This galaxy isn't lazy, it's efficient. It knows it has a long road ahead and it's pacing itself. Scientists still argue how long dwarf galaxies will keep forming stars as the universe expands and matter thins out. Will they adapt and survive well into the deep future? Or will they run out of fuel before the giant galaxies fade away? The models disagree and the debate drifts alongside you, like a pair of professors politely disagreeing over dinner. You leave the dwarf behind and drift toward one of the giants, a massive elliptical galaxy, glowing faintly red like embers in a dying fireplace. These galaxies were once overachievers fueled by countless mergers and starbursts. Now they're retirees. Their stars are old, red and stable. Their gas reservoirs are thin, their supernova rates low, their movements slow. The whole galaxy feels like a deep exhale, a thing that has done enough. As you fly over it, the stars move like dancers waltzing at half speed. No spiral arms whipping around, no shockwaves, no bright blue newborn stars, just gentle motion, serene and predictable. If the universe were a library, this galaxy would be the quiet reading room. And then drifting between these two extremes like a cosmic gossip, you sense the quirky fringe idea of this section. A handful of speculative theorists have proposed that dwarf galaxies and giant galaxies might experience cosmic expansion slightly differently. Not in any way mainstream physics accepts, but in the sense that their differing mass distributions could make them perceive time or space-time curvature differently. It's wild, unsupported, and charmingly impractical cosmic psychology for galaxies. But imagining large galaxies as old souls and dwarfs as lively children drifting into a slower universe that fits the mood perfectly. You drift upward, viewing both types of galaxies at once. In the early universe, interactions between them were common dwarfs merging into giants, giants stripping dwarfs of their gas tidal chaos everywhere. Now in the lazy expansion era, they rarely meet. They pass like ships in the night, nodding politely but never getting close enough to disturb each other. Scientists still argue how many more interactions remain. Will the Milky Way and Andromeda's eventual merger be humanity's last great galactic firework? Will small clusters keep merging for trillions of years, or will expansion isolate galaxies so completely they never touch again? The debate lingers like a long-forgotten voicemail. You drift closer to a peculiar pair, a dwarf galaxy, slowly orbiting a giant elliptical in a graceful centuries-long ellipse. It's such a gentle motion. No slingshots, no violent tidal arms, just a soft gravitational embrace. The giant barely notices. The dwarf circles quietly like a moon circling a sleeping planet. This is how the cosmic dance looks now, slow, calm, patient. Dwarfs drift around giants. Giants drift around clusters. Clusters drift away from each other as expansion opens the distance. Nothing rushes, nothing collides abruptly. Everything is settling into long, slow rhythms. You pass through the outskirts of the giant elliptical. The stars here are sparse, flickering like distant campfires. Their orbits are spread far apart. The gravitational influence is gentle, almost drowsy. Dark matter halos already stretched from earlier sections cradle these stars like soft blankets. Then you slip back into intergalactic space where the contrast between dwarfs and giants becomes conceptual rather than visual. Dwarfs survive because they're small and thrifty. Giants persist because they're massive and steady. Both adapt to the universe's new mood. Both drift deeper into the slow dance era. You glide onward, letting the cosmic music slow. The stars flicker, gas cools, gravity loosens. The dance continues without urgency. And you realize something soothing. The universe doesn't hurry its future, and neither should you. You float deeper into the widening quiet, carried by galaxies dancing at the gentlest possible tempo. You drift farther from the soft dance of dwarves and giants, and slowly, almost without noticing, you slip into a vastness so empty, so profoundly quiet, that even your imagination hesitates before stepping forward. This place has a presence, but not because something is here. It's powerful because almost nothing is. You've entered the silence between clusters, the widening cosmic voids that grow larger, deeper and more serene as the universe relaxes into its long exhale. It isn't darkness that defines this place. Darkness is familiar. But this is absence. This is stillness so complete it feels like the universe placed its finger gently to your lips and whispered, "Shh, not here." Here's your mainstream scientist-approved fact: cosmic voids already make up most of the volume of the universe, and they are expanding faster than the denser regions. Matter drains from them. Galaxies move away from them. Gravity barely grazes them. These voids aren't just empty, they're growing emptier. You drift into one such void now and the quiet hits you in waves. No stars, no clusters, no glowing dust. The nearest galaxy is so far away it might as well be fiction. Light here travels unbent, unchallenged, unstopped. It is perfect silence made visible, but not boring silence, more like the kind of quiet that makes you inhale deeper. Slow your heartbeat, let your mind unclench. The void isn't threatening, it's spacious. It's the universe's meditation chamber. Scientists still argue why voids expand as quickly as they do. Some attribute it purely to dark energy's influence. Others argue that the flow of matter from voids into filaments naturally deepens them. And a few fringe models, always eager to stir the pot, suggest voids could be bubbles in the fabric of space-time, expanding at rates slightly different from the rest of the cosmos. You don't need the equations. You can feel the expansion here. Not as motion, but as openness. Space becomes wide enough for thoughts to stretch their legs. You drift on and the loneliness becomes beautiful. There's nothing here to collide with. You distract you, pull you, or radiate at you. No heat, no light, no pressure. This is the quietest environment the universe can offer, the cosmic equivalent of lying down in a snow-covered field where sound disappears into softness. You travel another imaginary million light-years before encountering anything else. In that time, the void around you feels increasingly like a warm bath of nothing, a gentle neutrality, a reset, and then you see it, a single galaxy drifting across the void like a lost lantern. It's small, dim, stretched thin by expansion. You realize it has been traveling outward for billions of years, carried on currents of emptiness that grow deeper with every moment. You drift closer, and it feels like approaching a lone house in the middle of a sleeping countryside. A quirky fringe idea taps your shoulder right here. Some cosmologists have speculated that life-advanced life could seek refuge in voids in the far future. Why? Because as matter thins and radiation fades, voids provide long-term stability, low entropy, flux, and isolation from catastrophic cosmic events. The idea is half philosophy, half sci-fi. But it has an eerie appeal. Highly advanced beings choosing the quietest corners of reality for contemplation. You can almost see them strange ancient minds drifting through the cold on vessels made of pure thought. You leave the lone galaxy behind. It drifts away, swallowed by distance. Its light red shifts toward invisibility. Soon it will cross your cosmic horizon, and you will never see it again. You continue drifting. The void grows deeper. The silence thickens, but not in a heavy way. It's soft, pillowy. It feels like the universe is wrapping you in the most spacious embrace imaginable. Scientists still argue how big these voids will become. Will they grow to hundreds of millions of light-years across billions? Will expansion carve the universe into isolated pockets of matter, separated by endless oceans of quiet? Some predictions suggest that in the ultra-far future, the observable universe for any civilization will shrink to a single lonely galaxy, with everything else faded beyond reach. You drift past a slight ripple in the void, an area where the density is just barely higher than its surroundings, not enough to spark a galaxy, but enough to produce a faint gravitational texture. You sense it like a wrinkle in linen, nothing violent, just a suggestion that the void is not entirely uniform. You let that ripple pass beneath you and dissolve. And now the silence becomes profound. No stars, no gas, no dust, not even faint cosmic rays. Just you drifting through nothingness that feels strangely tender. You realize maybe for the first time that the silence isn't emptiness, it's permission. Permission to slow, permission to let go, permission to exist without needing to react to anything. Here the universe stops asking things of you. Here the void is honest. You drift on, absorbing the lesson wrapped inside this colossal emptiness. Sometimes the greatest presence is in what is no longer there. Sometimes silence is the universe's most generous gift, and you drift deeper into it, letting the widening void soften your thoughts as the cosmos stretches into the calmest version of itself. You drift out of the deep quiet of the void and into a wider awareness of the universe's slow transformation, something deeper than the stretching of space, deeper than the cooling of stars, deeper even than the fading of light. It's the quiet, steady hand guiding everything, the rise of entropy. And not the loud, chaotic version you hear about in school, the everything tends toward disorder mantra. No, this is the gentle version, the soft settling, the long exhale, entropy's gentle victory. You feel it first as a softening of patterns. Structures that were once sharp galaxies, clusters, filaments become blurred around the edges, not erased, not destroyed, just relaxed, like a sandcastle that remains recognizable even as the tide slowly smooths its edges. Here's your mainstream scientist-approved fact: entropy in the universe always increases because energy spreads out over time. Heat flows from hot to cold. Motion becomes less organized. Radiation disperses. Every process, no matter how complicated, leans toward equilibrium. But equilibrium isn't dramatic. It's peaceful. It's the universe settling into comfort. You drift into a region filled with ancient stars, red dwarfs, nearing the ends of their incredibly long lives. They glow faintly, feeding their last sips of hydrogen into fusion. The heat they produce spreads thinly across space, contributing to the great leveling. Nothing remains hot here for long. Even starlight stretched into long wavelengths adds to the slow approach toward uniform temperature. Scientists still argue whether entropy will define the universe's ultimate fate completely, or whether quantum fluctuations or dark energy might create exceptions. Some propose rejuvenation events, brief flare-ups of structure billions of trillions of years from now. Others insist entropy will win without interruption, guiding the cosmos toward a final equilibrium known as heat death. But out here, drifting, none of it feels dire. It feels natural, gentle, like a tide withdrawing from the shore. You pass an old galaxy cluster that once rattled with energy collisions, superheated plasma-wild gravitational dynamics. Now the cluster is quieter. The gas has cooled. The collisions have nearly stopped. Stars orbit slowly, losing momentum bit by bit. The cluster isn't dying. It's unwinding, letting entropy smooth its frantic youth into calm adulthood. A quirky fringe idea saunters in right on time. A few theorists have suggested that what we call entropy increase might actually be a kind of cosmic growth in information, like the universe learning to store its history more efficiently as it relaxes. They imagine entropy as memory, not decay. Mainstream physics doesn't endorse this, but it's fun to picture the cosmos as an old librarian meticulously organizing its books as it settles into twilight. You drift past a region where a star once exploded in a supernova. The shockwave has traveled so far and thinned out so much that it barely counts as movement anymore. Its edges blur into the background. Entropy at work, not violently but patiently spreading energy until nothing stands out. Ahead, you encounter a rogue black hole wandering through space. Once this object would have devoured gas and starlight, leaving a trail of entropy-producing radiation. But now, there's nothing to eat. It cruises silently, radiating only the faintest whisper of Hawking radiation, its slow contribution to cosmic dispersal. Even black holes eventually soften into entropy's long victory. Scientists still argue whether black holes will evaporate completely or leave behind some bizarre residual particle. Either way, entropy increases, order dissolves, energy spreads. The universe continues its drift toward uniformity. You glide onward into a region where everything feels balanced. Temperature gradients have all but vanished. No hot spots, no cold pockets. Everything is nearly the same gentle chill. Entropy has done what entropy always promised. It has leveled the cosmic playing field. You pass a dust grain floating through empty space. It rotates slowly, losing angular momentum by giving off faint infrared radiation. That radiation disperses outward forever, never to return. That tiny act is entropy increasing, and it feels soothing. A distant white dwarf emits a last few photons of heat. A rogue planet radiates away its final internal warmth. A fading nebula releases the last bits of starlight caught in its filaments. Everything gives slowly, gently contributing to the universal spreading out. You drift deeper into this softening universe and feel entropy not as an enemy but as a quiet housekeeper, cleaning up, tidying, smoothing, bringing everything into gentle balance. The galaxies no longer fight gravity's battles. The voids no longer echo with violent motions. The stars no longer burn with youthful intensity. Every system relaxes, every spark fades, every interaction unwinds, not tragically, not painfully, just peacefully. You realize floating here that entropy is not chaos. It's calm. It's the fading of tension, the evening of contrasts, the settling of the universe into a state where nothing needs to change anymore. A cosmic rest, a universal sigh. And as you drift in this soft expansion, you feel entropy working inside you too, loosening the knots of thought, smoothing the jagged edges of worry, spreading your attention gently across the moment until everything inside you reaches a quiet equilibrium. The universe relaxes, and you relax with it. You drift deeper into the universe's quietening future, and a strange sensation rises around you, not a sound, not a movement, but an absence, a dimming, a thinning, a sense that something fundamental is relaxing into near nothingness. It takes you a moment to understand it, and then it clicks. Even light is getting tired, not extinguished, not snuffed out, just stretched, smoothed, softened into wavelengths so long they barely count as light anymore. The cosmos isn't just cooling or expanding, it's redshifting itself towards silence. Here's your mainstream scientist-approved fact: as the universe expands, photons lose energy, stretching into longer wavelengths. A once blue photon might become red. A once red photon becomes infrared. Infrared becomes microwave. Microwave becomes radio. And radio becomes so long and lazy that detecting it is basically like trying to hear a single violin note on the far side of a sleeping city. You feel that dimming as you glide. Starlight from distant galaxies no longer sparkles, it sighs. Waves of energy drift past you like sleepy ribbons, too faint to illuminate anything, too stretched to warm even the emptiest dust grain. You've reached the point where light begins to give up. Not in defeat, but in acceptance. Scientists still argue whether photons losing energy through redshift constitutes a true loss, or simply a change in how energy is measured across expanding space-time. The debate flutters like a half-remembered dream, but every model agrees on one thing: the farther you look, the darker things get. You drift toward an extremely distant galaxy, one that once burned bright in the early announcements of the cosmic dawn. You can barely see it now. Its photons have stretched so much they flicker between detectability and silence. It's like trying to hear a lullaby sung from another dimension. You reach out, not physically but mentally, and feel the light sliding past you in waves the size of mountain ranges. Ahead, a rogue star emits its last visible light photons. They travel outward bravely, but by the time they reach the open void, they've already stretched into radio murmurs. Like a diary entry written in ink that fades as it dries, you catch one such stretched photon drifting past you. It doesn't glow, it doesn't heat, it's just a faint ripple in space-time whispering, "I was once something else." And here comes your quirky fringe idea, one that sparkles with late-night charm. Some theorists have suggested that at extremely long wavelengths, light might interact with the structure of space-time in ways that allow it to store energy rather than radiate it. According to this speculative reasoning, the universe's longest waves might become hidden reservoirs of information, or even serve as a kind of cosmic memory bank. Mainstream physicists raise an eyebrow at this, but you can imagine the universe hoarding memories in slow, stretched-out light, the way an old friend saves postcards. You drift onward. The light ahead redshifts further. Bright galaxies slip out of visible range entirely. They're still there, still glowing in their own frames of reference, but expansion has carried them beyond your ability to see. The cosmic horizon tightens, like a curtain being drawn by a very sleepy stagehand. You watch a quasar fade. Once the brightest object in the universe, it roared with radiation like a lighthouse of fury. Now it glows in wavelengths so long they feel like they're barely trying. It's like hearing an old rock star whisper a few last notes at the end of a concert that lasted trillions of nights. You drift through the fading glow of a star whose light is now stretched into microwave wavelengths. It radiates warmth so faintly that you could drift through its entire glow and barely notice. The photon density here feels like mist, not visible mist, but mist of meaning. The cosmos is trading intensity for longevity, brightness for softness. Scientists still argue what happens when all light redshifts beyond usefulness. Will communication across cosmic distances become impossible? Will any surviving civilizations huddle around their local stars, unable to see anything beyond their own gravitational neighborhood? Or will quantum processes create loopholes in the cosmic darkness? The debate drifts like redshifted static. You glide past an ancient galaxy cluster. Its once bright core now emits mostly infrared and microwave radiation. Even the background glow from all the stars, dust and gas within it is stretched into wavelengths that would have been undetectable billions of years earlier. Light is still here, but it's not shining, it's resting. You watch as a photon from a distant supernova, an explosion that happened ages ago, passes you. It is so stretched that one wavelength of it spans kilometers. It brushes past you like a slow wave, a reminder of a violent death now softened into a gentle hum. You drift on. The universe is dimming gracefully, not shutting down, just relaxing its brightness, easing its glow, letting everything stretch into gentle invisibility. And as the last faint glimmers of long wavelength light slip around you, you begin to feel something human in the cosmic redshift. You don't need brightness to see, you don't need intensity to feel. Sometimes the softest version of something carries its deepest truth. The universe isn't losing light, it's simply stretching it into a lullaby, and you drift inside that lullaby, now feeling the universe dim around you, not fading but settling into a quiet. It has spent billions of years learning how to sing. You drift onward through the dimming universe until a new sensation settles over you, something not quite melancholy, not quite peaceful, but undeniably tender. It's the feeling of endings that take their time, endings that don't rush, endings that stretch across billions of years like long, slow sunsets. You've entered the era of long farewells. Here the cosmos doesn't collapse or explode or scream. It sighs, it lingers, it lets every structure, every star, every orbit, every leftover ember of cosmic activity slip gently toward rest. Nothing ends abruptly. Everything leans into the quiet. You drift toward a fading star system. Once it had the youthful buzz of bright suns and restless planets. Now the central star is a faint red dwarf on the last leg of its near-eternal journey. Its glow flickers softly, radiating heat so slowly that its warmth will stretch across trillions of years like a drawn-out goodbye. Here's your mainstream scientist-approved fact. Red dwarfs will be the last shining stars in the universe, burning their fuel with unmatched efficiency. While massive stars died quickly, and even sun-like stars faded into white dwarfs, these tiny crimson lanterns persist, illuminating the late cosmos, one gentle photon at a time. You float past this star and watch its planets drifting in stretched orbits. Their rotations slow, their temperatures drop, their atmospheres, if they ever had them, have long since thinned into wisps. Yet everything moves with a kind of poetic patience. Nothing falls apart fast here. Scientists still argue how stable planetary orbits will remain in the universe's distant future. Will gravitational perturbations, passing rogue objects, or dark matter interactions eventually unbind planets entirely? Or will these long circling worlds remain loyal to their faint suns for unthinkable spans of time? The debate trails behind you like a gentle comet tail. You glide inward toward the innermost planet, a cold, dark sphere locked in perpetual twilight. Once warmed by the star's youth, it now receives only a faint rose-coloured glow. You skim above its silent mountains and frozen seas. Nothing moves, nothing breathes. But there is no violence in this stillness. It feels like a museum where every exhibit has settled into perfect undisturbed rest. You leave the planetary system and drift along the galaxy's aged spiral arm. Many stars here have already faded into white dwarfs, tiny hot cores slowly cooling over quadrillions of years. You watch one of them now, a faint point of light barely holding on to its last reserves of heat. It has no planets, no orbiting debris, just a slow decline into quiet. This is the long farewell of stars. They don't die anymore, they just dim. You drift farther and encounter a neutron star. Once a ferocious magnet, once surrounded by swirling disks and high-energy jets, now it spins slowly, wobbling with barely measurable magnetic pulses. Its brutal past softened by time, it radiates only faint heat, a cooling ember of a long-ago supernova. And here comes your quirky fringe idea for the night. Some speculative theorists propose that ultra-cold neutron stars might undergo exotic transitions, turning into strange quark matter, or even collapsing into tiny black holes over unimaginable time spans. There's no evidence for this, but imagining an ancient cosmic object evolving into something new in the universe's twilight feels weirdly comforting. You drift onward, past star after star entering their long fade, past planets slipping into eternal night, past comets that will never again feel stellar warmth. The galaxy itself is undergoing its own farewell. Star formation has nearly halted. The gas that once fueled its vibrant arms has dispersed. Stellar populations age uniformly. The galactic rotation continues slower than before, like a great wheel easing into a soft stop. Scientists still argue how galaxies will look when star formation ends entirely. Will they become loose collections of cold remnants, or will gravity gather the leftovers into stable, quiet configurations? No one knows, but every possibility feels peaceful. You leave the galaxy and enter the intergalactic darkness, where even long farewells become longer still. Rogue stars drift endlessly, cooling as they go. Black holes pass one another with casual indifference, no longer engaged in mergers or feeding frenzies. They radiate, evaporate, and fade on their own schedules. You glide past one such black hole now, its mass slowly evaporating through Hawking radiation. It's not dramatic, it's not explosive, it's the slowest farewell imaginable. A final whisper of heat escaping into the cold. You hover near it, sensing the slightest warmth leaking from its horizon, like steam from a cooling cup. You move on. Ahead, a once bustling star cluster is now a sparse arrangement of lonely red embers separated by light years. Time has stretched their orbits so much that encounters are rare. You drift through the cluster, feeling like someone walking through a quiet retirement home at midnight. Every star has stories, but none of them are rushing to tell them. Everything in the universe is saying goodbye, not mournfully, not dramatically, just gently. The universe is not ending, it's lingering, leaning into its forever evening, letting every structure savor its last traces of warmth, light and motion before settling into the quiet. And as you drift through this era of long farewells, you feel your own thoughts slowing, easing, softening, not ending, just relaxing. The same way the universe does. You drift onward through the era of long farewells until a new kind of question begins to form in the quiet space around you. Not what the universe is doing now, cooling, dimming, spreading, but what it will ultimately become. Will this cosmic evening settle into permanent night? Or will some unexpected flicker, some loophole, some deeply buried twist in the equations give the cosmos a second act? Welcome to the part of the journey where the universe starts feeling like an unresolved story. You've arrived at the crossroads of cosmology's greatest debates, heat death or something stranger. Here's your mainstream scientist-approved fact. The most widely accepted fate of the universe is heat death, a state where everything becomes uniformly cold, diffuse, and quiet as entropy reaches its maximum. No gradients, no energy flows, no stars, no structure. Just an enormous, perfectly even bath of near-zero temperature radiation. But you're not here to read the ending printed in the textbook. You're here to drift through the possibilities. And the universe, even in its laziest era, still has a few tricks left. You move through a region where old galaxies fade into the cosmic distance. Their light is so stretched by expansion that it barely counts as light anymore. You feel that familiar softness of dimming photons brushing past you like tired waves, and then beyond that, true darkness. This is the horizon of predictability. Beyond this point, theories diverge like paths in a quiet, foggy forest. Scientists still argue whether dark energy will continue accelerating expansion forever, or whether it might evolve into something else entirely. Maybe fade, maybe flip, maybe wrinkle space-time in ways no one has imagined. Your presence here, drifting through theoretical twilight, feels like reading sealed envelopes labeled open in 100 trillion years. You glide forward, and the quiet is so profound, you feel yourself leaning into it. The kind of silence that invites speculation. One possibility, heat death, the ultimate chill-out. Nothing happening, nothing changing. Everything flattened into cosmic monotony. The universe as the perfect, peaceful sleeping pill. Another possibility has a more dramatic title, the Big Rip. According to fringe models, if dark energy's push increases over time, it could eventually tear apart galaxies, solar systems, planets, atoms, and even space-time itself. It's the universe forgetting to be gentle and deciding to take everything with it in one final energetic flourish. Unlikely, yes. Fun to imagine while drifting through cosmic stillness. Also, yes. You float onward, and here comes another quirky fringe idea, strolling in like a theorist wearing pajamas at a physics conference. Some propose cyclic universes oscillating between expansion and contraction, like the universe breathing in slow motion. In these models, heat death might not be final. Entropy could be reset or reorganized into a new Big Bang. Mainstream physics raises flags here, huge ones, but the cosmic romance of rebirth is hard to ignore. You drift past a lone white dwarf, cooling into theoretical black dwarf territory, and the thought hits you. If a new universe someday blooms, would this cold remnant become part of its new chemistry? Would it remember anything? Would the new cosmos carry faint echoes of this fading one? The next possibility is even stranger: vacuum decay. Some theories suggest the universe exists in a false vacuum, a metastable state that could in unimaginable cosmic time spontaneously collapse into a lower energy true vacuum. A bubble of new physics expanding at light speed, instantaneous, silent, painless, like the universe updating its operating system. Scientists still argue whether vacuum decay is possible or just a mathematical ghost story. It might never happen, or it might happen tomorrow, or in 10,000 trillion years. Cosmology is a hobby for patient people. You drift toward a region where gravity is nearly given up, where density is so low it feels like pure potential. Here you imagine another theory: quantum rebirth. A handful of researchers have dared to suggest that quantum fluctuations in an ultra-cold universe might eventually spark new pockets of space-time baby universes, budding off like cosmic mushrooms. The idea is fringe, but you can't deny its charm. A universe growing weary, planting seeds. And then there's the one possibility that isn't a prediction but a confession: we truly don't know. You glance around at the soft stretched fabric of space-time, the cooling radiation, the fading embers of cosmic activity. Everything whispers, this is all heading somewhere, but no one knows exactly where. Maybe heat death is the final chapter. Maybe dark energy changes its mind. Maybe quantum rules rewrite themselves in the cold. Maybe the universe is dreaming up an ending we haven't imagined. You drift deeper into the quiet, feeling the weight of these possibilities. Yet none of them feel frightening. Not here, not now, because whatever the fate, it will unfold slowly, calmly, gently, on timescales so vast they make centuries feel like seconds. The universe is not racing toward ruin. It is gliding toward whatever comes next. And you drifting here feel that same patience settling into your bones, the comfort of not needing to know the ending to enjoy the story. The future may be heat death, or rebirth, or transformation, or something stranger than all three. But whatever it is, it's part of the universe's long, sleepy journey, and you glide forward into that uncertainty with quiet acceptance, matching the cosmos breath for breath. You drift onward from the crossroads of cosmic fate, carrying all those possibilities: heat death, rebirth, vacuum decay, cosmic mushrooms sprouting baby universes like quiet postcards from futures you'll never need to choose between. And as you glide through the stretched dim universe, something gentle settles into your awareness, your place in all this. Not in the grand, heroic sense, in the soft, personal sense that the universe's laziness, its cooling, its widening hush, somehow mirrors something inside you. You're no longer just observing the universe, you're inhabiting it, and it's inhabiting you right back. The cosmos isn't just expanding, it's giving you room, mental, emotional, existential room to relax. Here's your mainstream scientist-approved fact: every atom in your body was forged in stars' hydrogen, in the Big Bang carbon and oxygen, in red giants' heavier elements in supernovae. You aren't merely in the universe, you're made of its history. A condensed summary of billions of years of cosmic activity floating now through the universe's late-night quiet. You drift through a region where distant galaxies glow faintly like fireflies behind a fogged window. Their light reaches you in stretched, softened waves, longer, redder, slower. The universe is dimming, yes, but somehow the dimming makes your role clearer. You're a brief bright flicker against a backdrop that existed long before you and will continue long after. Scientists still argue about the philosophical implications of this cosmic connection. Are humans insignificant specks in an uncaring void, or are we rare pockets of complexity, temporary but meaningful, emergent like wildflowers growing from ancient soil? The debate moves softly around you like a breeze through tall grass. You drift onward, feeling the truth settle. You're not here instead of the universe's expansion. You're here because of it. You glide through a halo of ancient stars and notice something strangely comforting. Even though the universe is cooling and dimming, it hasn't stopped making room for you. In fact, the wide quiet seems to invite reflection. The softer the cosmos becomes, the clearer your inner voice feels. Cosmic laziness becomes mental spaciousness. The openness of the void becomes psychological breathing room. You drift into a sparse region where just a handful of old stars remain like distant campfires on a long-forgotten trail. Their faint glow reflects off you not physically, but metaphorically. Their persistence mirrors your own. Their slow-burning mirrors your steady steps through late-night thoughts. And right here arrives your quirky fringe idea of the section. A handful of thinkers, philosophers disguised as physicists have suggested that consciousness might not be an anomaly at all, but a natural response of the universe trying to understand its own changing structure. In this poetic speculation, minds arise because complexity arises, and complexity arises because the universe has enough time and space to make room for experiments. Mainstream science doesn't enshrine this, but it also doesn't forbid you from finding it beautiful. You drift farther into the cosmic quiet and feel something unexpected. Even though the universe is cooling, you don't feel cold. Even though it is dimming, you don't feel lost. Even though it is widening, you don't feel alone. If anything, the scale of it makes your smallness comforting. Because small things can rest, small things can let go. Small things don't need to hold the cosmos together. You pass through a faint filament of dark matter so thin it's almost philosophical. Gravity tugs at you softly, just enough to remind you that even in the emptiest parts of existence, something subtle is holding everything in place. Just like something subtle holds you in place even on hard nights. You glide through a region where the last traces of starlight scatter into gentle wavelengths. The glow touches you like the fading embers of a campfire at the end of a long evening. You feel how your own life, your joys, your regrets, your plans fit quietly inside a timeline that stretches for trillions of years. Somehow that makes everything feel lighter, not meaningless, just less heavy. Scientists still argue whether human presence in the universe is statistically improbable or inevitable, whether life is rare or common, whether intelligence is a cosmic accident or an emergent property of complexity. But none of those arguments matter here. Not in this quiet, not in this drifting. Because right now, the only truth that matters is the one you can feel you belong here. Not because the universe needs you, but because you are made of it. You're a small moment inside a vast, slow, relaxing whole. And as the universe stretches lazily around you, you realize that maybe, just maybe, your own expansion into calmness is the most natural thing you could ever do. You drift onward, held gently in the universe's widening palm. You drift gently through the soft, stretched quiet of the cosmos until a new kind of stillness settles around you, not the silence of voids, not the cooling calm of dying stars, not the dimming hush of red-shifted light. This stillness is deeper, softer, almost sacred. It's the feeling of a universe lowering itself into its final, most peaceful posture. You have arrived at a final rest in a cooling cosmos, not an ending, but a settling, a cosmic bedtime. The expansion continues lazy and patient. Galaxies retreat into private islands. Stars dim into embers. Black holes evaporate with long, whispering sighs. Space grows wider, smoother and colder, until even heat becomes too tired to move. Here's your mainstream scientist-approved fact in the far future of the universe: temperature trends toward absolute zero, settling into a state where no large-scale energy differences exist and almost nothing meaningful happens. This is known as the approach toward thermodynamic equilibrium. But you don't feel dread. You feel gentleness. The universe is not collapsing, it's not breaking apart, it's not screaming into oblivion, it's resting. You drift through a region where the last stars in a galaxy cluster have gone quiet. Their corpses, white dwarfs, neutron stars, black dwarfs float like cold stones in a dark pond. Their gravity still holds them in a soft choreography, a slow dance where the music has faded but the rhythm remains. A nearby black dwarf, the theoretical end state of a cooled white dwarf, glints faintly as a passing particle bounces off its surface. It's not bright, not active, it simply is, a quiet monument to everything that star used to be. Scientists still argue whether black dwarfs might eventually undergo proton decay or quantum collapse. Maybe they'll vanish into nothing. Maybe they'll spawn microscopic singularities. Maybe they'll simply sit forever in a universe that has forgotten how to change. No one knows. No one needs to. You drift closer to one of these remnants and feel nothing but calm. No heat, no radiation, no urgency. It's like sitting beside a friend who doesn't need to speak for you to know you're safe. Farther out beyond any remaining galaxies, you encounter the wide ocean of stretched blackness, so uniform, so smooth it feels like sliding your hand across satin. The cosmic microwave background has redshifted beyond microwaves now. It's stretched into low, slow radio waves. Eventually it will fade beyond detectability. And here comes your quirky fringe idea of the section some theorists have proposed that consciousness, or something like it, might survive as low-energy information patterns drifting through the ultra-cold vacuum. The universe itself, in this poetic speculation, could become a kind of dreamer, thinking in ripples stretched across eternity. Mainstream physics raises a skeptical eyebrow, but you can't deny the poetry of a universe humming quietly to itself at the edge of time. You drift deeper into this hush. You pass the faint warmth of a decaying black hole, evaporating through Hawking radiation. Its final photons glow like the last sparks of a dying campfire. One spark passes through you, a soft kiss of energy travelling across trillions of years just to say hello. You move onward. Space stretches more, temperature falls, activity fades, but nothing feels lonely. The universe is not empty, it's full of rest. Every process that once roared has slowed to a whisper. Every star that once burned has settled into calm. Every chaotic interaction has unwound into serenity. Scientists still argue what truly comes after this cosmic quiet: heat death, quantum rebirth, vacuum decay, eternal stillness. But drifting here with the universe relaxing beneath you, the debates feel distant, they're stories for another time. Tonight you're here, floating in the final softness of a cosmos that has grown wise, patient, and profoundly peaceful. You close your eyes, not literally but in the way your mind softens, and feel the universe breathing around you. A breath that lasts trillions of years, a breath that carries you with it. The universe is resting. And as you drift through its quiet, cooling expanse, you feel something settle gently inside you. Too, not an ending, but an acceptance. A quiet alignment between your heartbeat and the soft pulse of a cosmos easing into stillness. You belong to this universe. You are born from its heat. You drift within its calm, and when it rests, you rest with it. The long journey through expansion, cooling, dimming, and drifting brings you here to a place where everything is soft, where time stretches, where thoughts slow, where nothing pulls at you anymore, a universe unwinding, a traveller at peace, and you let yourself float. The universe settles into its great quiet, and you drift with it, letting every thought become a long, gentle ripple that softens as soon as it forms. There is no rush now, no brightness tugging at your attention, no urgency in the cosmos and no urgency in you. Everything stretches into a calm, slow rhythm, longer breaths, softer thoughts, wider spaces inside your mind. The last traces of starlight fade to a faint hum across eternity, but instead of feeling like loss, it feels like the soft dimming of a bedroom lamp at the end of a long day. You can almost feel your own edges soften the way the universe's structures softened over trillions of years. You're not disappearing, you're simply easing into rest the same way galaxies eased into distance. As you drift, you sense the memory of warmth lingering in the universe, not heat, not brightness, just the memory of motion. A reminder that things once burned brightly and that brightness made you possible. That even in a cosmos growing colder, the warmth you carry inside you is enough. Let everything slow now. Let your breath lengthen. Let your thoughts open, drift, and dissolve like faint cosmic dust. The universe is so wide and yet it makes room for you. There is space, endless, gentle space for you to let go of the tightness in your shoulders, the noise behind your eyes, the small gravitational pulls of your worries. They drift outward, carried away on the same expansion that softened galaxies. You are held inside this late universe calm. You are floating in a place where nothing is asked of you, where nothing needs to happen, where everything has already been gently allowed to settle. The emptiness around you isn't empty at all, it's fullness made quiet. Like a deep breath held in the dark, like the ocean at night when the waves finally tire, like snow falling in a world with no wind. Let yourself feel that quiet, the safe kind, the kind that supports you rather than isolates you. Your thoughts become softer, slower, farther apart, small lights drifting into the distance just like the galaxies did. And as they drift, the space between them becomes restful, spacious, kind, You're allowed to rest here. You're allowed to sleep. You're allowed to drift without direction or purpose, carried by the universe's long, slow pulse. Let the last of your awareness expand outward, dissolve into the softness and settle into the stillness that has been waiting for you. A stillness older than stars, older than galaxies, older than even the first light. The universe is resting, and now, so are you. Thank you for being here. Where in the world are you watching from today?